all the eminent dignitaries, delegates gathered here. I humbly request all the dignitaries to take their seats on the dais. Please, sir. Good morning and a warm welcome to each one of you to the much anticipated conference, Pharma Frontiers 2025, AI Assisted Innovations in Pharmaceutical Sciences. It is both a privilege and a pleasure to have you join us at this landmark event where we are about to embark on an exciting journey into the future of pharmaceutical sciences. This conference is not only a gathering of brilliant minds, but a platform where groundbreaking ideas, innovative solutions come together to shape the next era of healthcare. I, Sneha Bhosle, feel privileged to extend a warm welcome to Honorable Dr. Pranati Tirak Ma'am, Director, Lokmanya Tirak Institute of Pharmaceutical Sciences, Honorable Dr. Rohit Tirak Sir, Vice President TMV, Respected Secretary TMV, Mr. Ajit Khadilkar Sir, Honorable Mahesh Zagade Sir, Ex-Principal Secretary Government of Maharashtra, Dr. Meenakshi Devdar, Principal LTIPS, Dr. Meera Deshmukh, Registrar LTIPS on this notable event. Thank you for gracing us with your presence. Honorable Dr. Deepak Tirak Sir, President TMV, has conveyed best wishes for successful and impactful national conference. On the precipice of a new age in pharmaceutical sciences, we are faced with a unique opportunity to harness the power of collaboration, innovation, and research to address some of the most pressing challenges in medicine today. We will delve into a world of dynamic advancement from cutting-edge drug delivery systems to the revolutionary impact of AI in drug discovery to the rise of biopharmaceuticals and biotechnology in treating complex diseases. The discussions and the insights shared today will no doubt guide and inspire the work that lies ahead, propelling us towards safer, more effective treatments and ultimately better healthcare outcomes for people around the world. Lightening the lamp represents enlightenment and dispelling of the darkness. We have come together to respect this symbolism and express our wholehearted gratitude towards ageless knowledge that directs us. I now request our dignitaries to proceed for the lamp lighting. Thank you so much, respected sir and respected ma'am. Before we begin this splendid occasion, let us invoke the blessings of Goddess of Knowledge and Wisdom, Ma Saraswati. We are delighted to present a captivating welcome song performed by our students.
Agyana udadise, Thank you for the mesmerizing performance. My warm regards to the dignitaries on the dais. LTIPS is emerging as one of the top pharmacy colleges because of its innovative culture, dynamism, and perseverance in searching out and implementing creative approaches. With a 102 years illustrious history, Tirak Maharashtra Vidyapeeth has been a prominent educational institution from 1921. With its current presence, TMV has demonstrated its superiority in delivering modernized national education. The university provides education in an array of disciplines such as pharmacy, management and commerce, Ayurveda, social sciences, Indology, social work, mass communication and journalism, foreign languages, physiotherapy, nursing, hotel management, law, and computer science. The mission of LTIPS is to prepare the students to become responsible pharmacists and aims to provide quality education that effectively integrates critical thinking, problem solving, ethical values, and leadership skills. As we embark on this remarkable journey of knowledge and innovation, we are truly fortunate to be in the esteemed company of distinguished personalities who will guide and inspire us. On behalf of LTIPS, I welcome Mr. Mahesh Zagde sir, a highly respected consultant, motivator, and public speaker whose influence has made a significant impact across both the public and private sectors in India. Having served as the ex-principal secretary to the government of Maharashtra, his contributions have been truly outstanding. I kindly request Honorable Vice President TMV Dr. Rohit Tirak sir to present a token of our gratitude by felicitating our keynote speaker, respected Mr. Mahesh Zagde sir. Thank you, sir. The Vice President of TMV, Dr. Rohit Tirak sir, has played a pivotal role in elevating the standards of this institution. I hereby request Principal LTIPS, Dr. Meenakshi Devdar, to felicitate Honorable Vice President sir. Thank you, sir. Thank you, ma'am. LTIPS owes much of its success to the unwavering support and mentorship of Honorable Director Dr. Pranati Tirak ma'am, whose tireless efforts have been instrumental in the establishment and smooth functioning of this institution. I would like to request Registrar LTIPS Dr. Meera Deshmukh to felicitate Honorable Director ma'am as a token of our gratitude. Thank you, ma'am. I now again request Registrar LTIPS Dr. Meera Deshmukh to felicitate respected Secretary TMV Mr. Ajit Khadilkar sir. Thank you, sir. Thank you, ma'am. To begin with, I humbly invite Principal LTIPS Dr. Meenakshi Devdar to deliver the preamble and offer a valuable introduction to the conference.
Thank you, Apurva. A very good morning to the respected dignitaries on the dais, my very dedicated teaching and non-teaching colleagues, our wonderful students, and all the student and faculty delegates across the nation who are present here, and all those who are attending this exciting event online through our YouTube channel. It's my great pleasure to welcome you all to the second day of Pharma Frontiers 2025, AI-assisted innovations in pharmaceutical sciences. Innovations in pharmaceutical sciences have significantly improved our lives by advancing the development of medications that prevent, manage, and cure a wide range of diseases. Breakthroughs in drug research have led to life-saving treatments for conditions once considered fatal, such as cancer, diabetes, and heart diseases, while also enhancing vaccines that protect us from infectious diseases. Additionally, the rise of personalized medicines allow treatments to be tailored to individuals' genetic profiles, ensuring more effective outcomes. These advances have not only extended life expectancy, but also greatly improved the quality of life of millions of people around the world. Among the latest innovations shaping the healthcare landscape are gene therapy, mRNA vaccines, immunotherapy, AI-assisted drug discovery, and nanomedicines. Moreover, herbal medicines are now taking on a all-new dimension thanks to the advanced analytical techniques that have helped to enhance their quality. Pharma Frontiers 2025 aims to bring together researchers and professionals from diverse fields, but with the common focus of improving human health, to share the exciting innovations taking place in pharmaceutical sciences. I am pleased to share that we have received over 500 registrations for the conference, with approximately 80 participants presenting their papers yesterday. These presentations were judged by esteemed faculty from reputed colleges of Pune. I would like to extend my heartfelt thanks to Dr. Amelia Outsat, ex-professor, Sinhagad College of Pharmacy, Dr. Ajay Kare, Associate Professor, Navsayadri College of Pharmacy, and Dr. Rahul Padarkar, Assistant Professor, AI SSMS College of Pharmacy, for taking the time to evaluate these presentations and offer their valuable feedback. So yesterday on 30th Jan 2025, 46 presentations were made under the undergraduate category and 33 presentations from the postgraduate, PhD and faculty category. I am very glad to inform all the participants that all the judges unanimously praised the quality of the papers presented, and I totally understand that you all are anxious to know the results of the same. But just hold on a little longer, as the results will be declared in due course of time. Thank you for your patience. Today, on the second day of conference, we are excited to offer talks on a variety of topics ranging from nanotechnology to stem cell research. The first lecture of the scientific session will be delivered by Dr. Vandana Patravade, Professor, Pharmaceutical Sciences and Technology, ICT, Mumbai. A renowned expert in nanotechnology, Dr. Patravade will elaborate on this rapidly growing field. Following this, Dr. Sriram Inamdar, Director of Operations at Xylem Research, Pune, will share the latest advancements in cancer therapeutics and awareness. In the afternoon session, we have Dr. Prasad Thakur Desai, Chief Scientific Officer at Indus Biotech Limited, who will shed light on how herbal medicines are revolutionizing disease treatment. Our final speaker of the day is Dr. Savita Datar, ex-professor and principal of SP College, Pune, who will discuss the nuances of stem cell research using chick embryos. Dear delegates, we are privileged to have with us none other than Mr. Mahesh Zagde, ex-principal secretary to the Government of Maharashtra and ex-commissioner of FDA, who will deliver the keynote address. Sir, your contributions to the field of pharmacy are unparalleled and continue to inspire us all. We are also honored to have respected Dr. Rohit Tirak, esteemed director of LTIPS, Dr. Pranati Tirak, with us today. Their constant support and attention to details have been instrumental in making Pharma Frontiers 2025 a great success. Your presence, sir and ma'am, here motivates us to strive for the best. I also welcome Mr. Ajit Khadelkar, Secretary TMV, and Dr. Meera Deshmukh, Registrar LTIPS. So dear delegates, let's get ready to enjoy the offerings of the day by deliberating on the thoughts shared by our esteemed speakers. I request you all to interact with the speakers freely and thus fulfill the objectives of this incredible event. So, welcome again to the Pharma Frontiers 2025 AI-Assisted Innovations in Pharmaceutical Sciences. Thank you.
Thank you, ma'am, for delivering the preamble of today's session. Your words have truly set the stage for today's discussions and highlighted the immense potential of AI in transforming the pharmaceutical sciences. Now, on behalf of LTIPS, it is my immense privilege to invite Honorable Director LTIPS, Dr. Pranati Tirak, ma'am, to deliver the presidential address. Please, ma'am.
Thank you, Apurva. A very good morning to everybody. Respected Mr. Mahesh Zagde, sir, dignitaries and my colleagues on the dais and off the dais, dear students. The main focus of this two-day national conference is the most exciting and transformative forces in modern healthcare, artificial intelligence. AI and its significant impact on the pharmaceutical sciences. The pharmaceutical industry has long been at the forefront of scientific innovation, but with the emergence of AI, we are witnessing a major shift in how we approach the problems that have for decades seemed daunting. AI is reshaping the landscape of drug discovery, development, and delivery, also transforming pharmaceutical sciences across multiple stages from drug discovery to clinical trials and manufacturing. In drug discovery, AI accelerates the identification of potential drug candidates by analyzing vast data sets and predicting molecular behavior, enabling faster, smarter decision making and targeting diseases like cancer and Alzheimer's. During clinical trials, AI optimizes trial design, predicts ideal candidates, monitors patient progress, and helps identify potential side effects, improving both efficiency and patient safety. In drug manufacturing, AI streamlines production, enhances quality control, and supports personalized medicine by tailoring treatments to individual patient profiles. This integration of AI across these areas is revolutionizing the industry, making drug development faster, more accurate, and more personalized. What ties all of the speakers of the conference together is a shared vision, a vision for progress, innovation, and collaboration. Whether in drug discovery, healthcare technology, or global health policy, the plenary lectures of these eminent speakers are surely going to help in shaping the future of you, dear students, and professionals at large. The contributions will spark important conversations and inspire new ideas that will drive us forward as a community of professionals dedicating to advancing knowledge and improving lives. You are all fortunate to have a lineup of experienced, eminent speakers who will be sharing their knowledge, insights, and expertise over the course of the event. As director of the college, it is my duty to remind all of our students to treat this conference as a valuable resource for gaining important knowledge and for thinking beyond your classrooms. You will be informed about all the potential opportunities that you can explore in the professional world. You will also be able to think of avenues that can link you to the industry during your degree program as well. Dear students, you have a fountain of knowledge that has walked up to your doorstep. You have to ensure that you utilize this opportunity to maximize your growth and gain insights for a bright, successful future. I wish the entire team of Lokmanya Tilak Institute of Pharmaceutical Sciences good luck and wish you all happy learning. Thank you.
Thank you, ma'am, for your presidential address. Your vision and guidance continues to light the path for all of us in this field. As the adage goes, leadership is not about being in charge, it's about taking care of those in your charge. Thank you once again, ma'am. With a great honor, I introduced our esteemed keynote speaker of today's session, a person whose exceptional career spans across various areas of leadership, governance, and inspiration. With his vast experience and visionary insights, we are incredibly fortunate to have him with us today. I am elated to introduce keynote speaker of today's conference. Mr. Mahesh Zagde is a retired Indian Administrative Service Officer, highly respected consultant, motivator, and public speaker. He has served as an ex-principal secretary to Government of Maharashtra. With a career spanning over 37 years across both government and private sector, he has participated in numerous prestigious public administration training programs both in India and internationally, including courses on leadership and change management. Sir has been honored with several prestigious accolades such as World Health Organization International No Tobacco Day Award in 2014, as well as national honors like National Gold Award for E-Governance 2012 and 13, President Silver Medal for the Census 2011. His expertise spans a wide array of fields including public and corporate administration, agriculture, rural development, urbanization, education, health, sustainability, making him an influential leader. Currently, Mr. Zagade sir continues to offer his invaluable expertise to a diverse range of stakeholders, including corporates, students, government officials, healthcare professionals, etc. He remains dedicated to share his vast knowledge and experience through public engagements, seminars, workshops, aiming to impact society positively. Now, I humbly request respected Zagade sir to proceed with his session. Please, sir.
Thank you and good morning to you all. Dr. Rohit Tilakji, Dr. Pranati Tilakji, Dr. Minakshi Devdarji, Ajit Khadilkarji, Meera Deshmukhji, and my student friends and staff, and those who are attending online. It really gives me immense pleasure to be with you and to appreciate the organizers and all those who are connected with this, that they have conceptualized the title of this conference as AI-assisted innovations in pharmaceutical sciences. Today, everyone here talks about artificial intelligence, and I hope with artificial intelligence, we should not forget the natural intelligence. And it has been spoken so much. So today, when we talk about the use of artificial intelligence in pharmaceutical sciences, let's keep intact our natural intelligence also, biological intelligence also. When I scan the literature, when I scan the happenings across the internet, what's happening in the world, and I sometimes I get fear that probably the organic intelligence is going to take backseat. This is very horrifying thought for me, thought for a person who probably is of the earlier generations and you are for the future generation, but it's a very scary thought. And that thought emanates from some of the key factors, like after 1940s and 50s and 60s, we do not find many fundamental researchers like your innovations in terms of discoveries and inventions, like what happened E is equal to MC square and all that, which used to happen as a fundamental inventions. Today we are the products of the applications. Whatever was invented or discovered till 50s, 60s or up to 70s, we are developing our structures on that through applications to development. And probably the creative machine of the biological intelligence, whether it is going down, that really poses the question. So I think in a way we are being too easy in adopting such technologies like artificial intelligence, and we are giving backseat to the natural intelligence, and one day probably then I have a fear that this artificial intelligence could take over the humanity. It has got that kind of potential. Of course, it is yet to be, we are still struggling to understand whether the artificial intelligence could get the consciousness that the organic brain that has. But I'm not bothered about whether the artificial intelligence is going to develop consciousness or not. Without consciousness also, it is going to change the humanity, and probably the humanity could turn into humanoid kind of existence through the use, or then I will use the word misuse of artificial intelligence, and to get subdued under the onslaught of artificial intelligence. But we have to live with one thing, that we cannot really ignore what is happening across the world in the realm of artificial intelligence. We have to be part of it. And if we are not going to be part of it, we'll be left out, as we had been left out in the first industrial revolution that started in 1776, when the steam engine was developed. Then second industrial revolution that started in 1840 and 60, when internal combustion engine and use of electricity had started for mass production of various products. And of course, the third industrial revolution we started as a computerization in 1960. In all these industrial revolutions, India was relegated to a position which was nowhere. Now we are in the fourth industrial revolution, which started probably around sometime in 2011-12, and artificial intelligence is part of it. Now, if we miss this bus, then the most populous country on this planet would be will be nowhere then. In fact, till 1750, India was one of those two countries in the world which were economic superpower, China and India. In fact, 26% of world GDP used to be captured by India till 1750, and that was because of the agricultural field that was driving this planet. But with these three industrial revolutions and with the fourth industrial revolution, India has been relegated to a very minuscule kind of position. Now, this is the time that we must we must capture the imagination of all the society and the country, and we should really reap advantages and reap dividends from the artificial innovations kind of technologies. If we miss this bus, probably we would lose this bus permanently. Now the world is not going to be so kind to us. We may be having that we are the third or fourth or fifth, whatever the rank that we are holding in GDP in the world. But if we compare that GDP with the per capita income of this country, we are nowhere. See, if USA is having $24 trillion of economy, and we are having say $3.7 trillion of economy, and we are fifth or we are fourth, that is immaterial, because our per capita income is around $2,200 to $2,300, where the USA, we cannot be compared with that. If we want to be really economic superpower like America, then instead of $2,300 per capita income, we'll have to increase our per capita income as that of USA, and to do that, we'll have to increase our GDP from 3.7 trillion to $110 trillion, which is the GDP of the entire world. Will not becoming superpower if you just become like a $5 trillion economy or $7 trillion economy. If we want to be like a superpower, economic superpower, our economy has to grow to the level of $105 to $110 trillion. So this must be kept in mind, and then for that, these artificial intelligence innovations in various sectors, not just pharmaceutical, is one of the tool that we can look up at the world, where we can once again be leader like we were leader before 1750 during the regime of agrarian economy. Now, having said that, you have the community that is connected with 1.57 trillion economy of the world. That is, the pharma size is probably 1.7 trillion economy, or you have got different figures. Different statistical resource sources give different figures. My current figure is $1.57 trillion, which is slightly less than entire India, this country. The most populous countries, less than half economy, GDP, is the size of pharma sector in the world, and you are going to be part of it. We are like, say, a third in terms of manufacturing the total pharma products in the world, in terms of the size of it, in terms of the volume. But in terms of the value, how much are we? At what level? Not at number 3 in the world, but at 13th, 14th, 15th level of these things. Our value, that the produce that we manufacture in India, and since we are talking about the pharmaceutical innovations, pharmaceutical sciences, basically manufacturing, we are talking about a generation, we are too minuscule. So with these artificial intelligence technologies, we have to travel from being 13th ranked country in terms of value to at least rank number 3, which would match the volume. So volume and the size, economic size should match. So we have to take to the, at least that should be the objective of the Indian innovators in pharmaceutical sector, that we have to somehow get into the wagon or the bandwagon of the train where the size and the value of pharma products manufactured in this country could match at the rank number 3. How to do it? You have to discuss, decide, innovate. I am not a pharmaceutical graduate. I don't know anything. But I am just a student of a pharmacy. I just look it from outside. Another factor, this time of window of time is completely different. Gone are the days when you used to go in laboratories, do titration and all those things. This laboratory, no. Here with the artificial intelligence, and probably you must have seen this product software, Co-Scientist. Have you seen that Co-Scientist? Co-Scientist is a virtual laboratory. That doesn't have any physical laboratory. You can go take a molecule and see how it behaves in cyberspace, and then you see that how it reacts with the other chemicals, and you come out with the kind of reactions that is there. So you no longer are you do not require physical infrastructure, and this is mainly assisted by artificial intelligence, and this is just a beginning. So in a few years' time, probably all, if not all, most of all physical laboratories would be eliminated, and we should be ready for this. Academic institutions should be ready for this. In fact, you should start your own co-scientist type of virtual laboratories in academic institutions so that the students can innovate. You all know that 95% of the manufacturing units in the world, pharma units, they are using artificial intelligence, and 80% of the companies are new ventures are getting invested. The investment is coming in artificial intelligence sector. Where are we in India? If you consider this, compare with the world investment and how many companies are engaged in usage of artificial intelligence, we are nowhere. And that's where your role comes in. You, as the young scientist, young entrepreneurs, young managerial persons in this field, pharma field, you must assimilate the technologies that have been made available to you through the artificial intelligence technologies today. Unfortunately, how many molecules in India are getting developed, and out of those how many molecules, how many are artificially assisted molecules are getting developed? We do not have the own figures also how many molecules are getting developed in this country. Forget about how many molecules are coming through the artificial assisted innovations. The timeline that was required earlier, 5 to 6 years, what was the timeline in the laboratory for discovery of molecule, or it is more than that? 13 years. Through AI, it has come down to 1 year. Just 1 year. And the amount of money that is spent also comparatively gets reduced. So for a country that is not so affluent like USA or China or other innovating countries, then probably this is the best tool that we have, since we do not have resources. But with the artificial initiation technologies, we can make use of technologies and reduce the timeline of discovery of molecules. Now, why doesn't it bother you all? If in terms of volume we are third in the world, and in terms of value we are 13th or 14th, why can't we go up? Because one thing, we are not discovering molecules and we are not taking international patents. How many pharmaceutical patents in international arena we are coming? That you should ask yourself how many patents we are developing. After say 1980 and 1990, the whole world, entire world is moving on the bandwagon of the intellectual property rights and the money coming through it, and in normal parlance it is patenting. Today, if you scan the world of patenting, intellectual rights, intellectual property rights, and the GDP generated out of it, it's a very, again, scary picture for India. USA probably is having 43 lakh patents with them, international patents. China is about 30 to 33 lakh patents. Japan is having 20 lakh patents. How many international patents India has? We are minuscule. Today, new patents, if you see the new patents coming up, it is China number 1, USA number 2, Japan number 3, and country like South Korea, which is probably half of the population of Maharashtra, forget about country. They are coming out with the large number of patents, and if you see the last 2-3 years, most of the patents are coming through the AI assisted technologies. Where do we stand? I think the conferences like yours, today's conference, it should be our motto. We should develop a strategy, we should develop a countrywide policy that we must incorporate AI into every innovations in every field, including pharmaceutical. Another factor that is very important is for pharmacists, it is no longer like your chemistry, biochemistry, anatomy, physiology and all that. Forget about all that. It's there, and how the chemical molecule reacts with the system, how the physiology of the organism, pathogens works and all that, that is there. But today, with this AI, it is also the job of digital experts. It is no longer you are the biological experts, but the digital, if you want to take assistance of AI, there has to be a digital expert, maybe a software, maybe an engineer, or maybe combined together too. Unless and until you have partnership with that, we are not going to make any inroads into the field of innovations. You alone, stand alone, cannot do that. You may be expert in pharmacology. You may be expert in how biochemistry works there. But unless and until you have interface with the digital technologies, your knowledge is not going to be utilized in the realm of AI assisted technologies. So there has to be marriage between the biological sciences and the digital sciences. Unfortunately, the PCI has not considered this aspect till today. And through this forum, I must really appeal to the PCI, they should wake up. In fact, they have been sleeping for last 70 years, 70, 80 years. And I have a right to speak because I am a patient. And patient can definitely speak about what I require from PCI also. Now, whatever happened in the past, let it happen. But for the future, they must take cognizance that the pharmacology or pharmacist science alone should not be the innovator. It has to have interface with the digital technologies, and that kind of curriculum has to be developed and has to be married to each other. Otherwise, it is going to be just like any other day, like some people get admission, they graduate, they join industry, some join academia, some join business, but that's it. So that will keep us like 13th or 14th in terms of value, and we will not be world leaders in pharmacists. We have a chance to become world pharmacy of the world. We do have chance. We do have immense intellectual data property in youth today. We have too much of intellectual assets that we have, but if you are not going to make use of them as what is required in the future, we should not be getting dragged. What happened in USA, what is happening in China, or what happened in some other countries. We should be thinking more than what they are thinking, and I think the thinking should come through the this marriage of the biological sciences and the physical sciences. As it is, leave that aside. The fourth industrial revolution technologies are going to change the face of the planet. Artificial intelligence, cognitive analytics, genomics, and robotics, 3D printing, and everything. 3D printing is going to come in your pharmaceutical industries also, like tailor-made medicines. I'm not going to talk about it because that is for your. My only issue is that the fourth industrial revolution technologies are going to it's not these technologies, what I said, genomics, artificial intelligence, cognitive analysis, no. I don't consider it to be fourth industrial revolution technology. What I consider is the merger of biological and physical. And that is going to happen for the first time in last 380 crores of years. 380 crores of years ago, a life was created on this planet in the early broth of sea, where the larger molecules came together and they created protein, and out of that protein, of those proteins, complex proteins, and the life form was generated on this planet. After 380 crores years after that, today we are again at the juncture where similar kind of revolution is going to be experienced on this planet, where biological and physical is going to be merged. Now for that, you people are to be braced up. Now if you come to the, if you think about what is the future of pharmacist or the pharmacy industry in the world. Today the products is all product based. You are creating products, you are conceptualizing products, you are developing those products, you are marketing those products, and then that's how $1.57 trillion are earned by this industry from the patients. And that's basically from promotive health, preventive health, and curative health products. This regime is going to change permanently. Your promotive health products, preventive health products, curative health products are going to get eliminated simultaneously, slowly. And when I use word slowly, it is also not correct to say slowly. If you think about the Moore's law, how many of you know Moore's law? 1971, if you consider Moore's law, like every 1 year, the transistors or on this chip, how many transistors can be accommodated, that's how the processing capacity of the processor goes up. That is like double, every year it doubles. That is the microprocessor. Intel's Moore developed this law. But if you take that law, I am talking in terms of the speed at which the innovations are happening. If 1971, the Moore, processor, Intel processor, if you consider that, and if you consider its today's efficiency, it is 3,500 times more efficient. It is 60,000 times faster, and it is 90,000 times more energy efficient. So this is Moore's law. Now if you consider it as a car, car getting manufactured in 1971, if it had developed in the same kind of fashion like the microprocessor, today this car would have a speed of 480,000 kilometers per hour. Now why I am saying, giving you these figures, today when I said things are changing slowly, no. The change of innovation is also changing so fast, breakneck speed, and with this artificial intelligence, this speed is going to go phenomenally high. So when I said the promotive, preventive and curative health products are going to get eliminated slowly, no. Slowly word is very wrong. Probably it may get eliminated very soon, all these products, what you call drugs. What is going to happen? With the advances in genomics, there could be like CRISPR-Cas9 technologies are going to come in. In fact, CRISPR-Cas9 has also become very old. There are some new technologies are coming out, but because of the patenting, they are not releasing it out. With these technologies, if the genomic changes are effected, then probably you will not get any disease. The world is moving towards the research projects where you will not get any disease. If you are not going to get any disease through these technologies, then promotive health, preventive health, curative health products will have no market at all. This industry is going to get redundant. So it is the extreme end of it. You have to be prepared for this, and I hope with this kind of conferences, this seed of thought could start getting germinated in your minds. This is far, but if you take the case of GBS, Guillain-Barré syndrome in Pune, we are struggling to find out what it is, how it comes, how it spreads. The world is at that end, and we are at the level that we do not know what is happening. So there is a big void between in India that where the world is and where we stand. I hope these kind of conferences can also focus on how to bridge this gap. What is the ground reality and what is there in the world? If you consider the, like for example, drug resistance, nobody talks about the drug resistance these days because it is taken as okay, it does happen. But drug resistance, why does it happen? Why it should happen, and how AI technologies can stop this drug resistance? Drug resistance, if you consider, like this Salvarsan was the first antibiotic that was discovered in 1908, and then 1928 penicillin. Then it started. But between 1942 and 1963, 25 antibiotic molecules, antibacterial molecules were discovered. But from 1962 to 1987, maybe 7, 8. But since 1987 till today, how many new antibacterial molecules have come in the market? How many? Any idea? I do not know whether any new one had come in 2019, but I do not know whether its efficacy or. That means there is big void. At one end, all antibacterial and antimicrobial products are getting, they develop resistance. But at one end, other end, no new molecules are coming, and there's going to be a scarcity of these molecules. That's where probably the artificial intelligence can work. So today you're only talking about the AI-assisted innovations in pharmaceutical sciences. I think that can be extended to the manufacturing also. Mainly clinical trials. Clinical trials can, this is again another sphere where everybody looks upon the clinical trials as a very big scam across the world, and there could be some scams also, but nonetheless, we have to be very, very scientific in clinical trials, and AI-assisted technologies can become one tool how to make them really scientific and how the patients can get benefited, because clinical trials are spearheaded by the companies that they patent, those hold patents, and there are chances of getting some kind of support from the regulators, and some products may be getting approval without proper clinical trials or the vitiated clinical trials. But with these assisted AI-assisted technologies, I think this loopholes can also be plugged. Third is about the distribution cycle of the medicines right up to the patient can also be tackled through the artificial innovation technologies. Now, it's very easy to say this, but it's not like for student community. You are an individual now research laboratory. This opportunity is being afforded to you through assisted, artificial intelligence assisted technologies. Now you can forego the use of colleges' laboratories. You yourself can be a laboratory. You can think about it, get some application. There are many, at least I know 8-10 applications where the pharma laboratories or the product of this technology can be used, and you yourself can start developing the product, or how a virus reacts with the DNA or RNA of this human cell, what happens, what products are there, how these products can be countered. You yourself can do wonders with these AI applications with you, so you become an independent laboratory. Every student can become an independent laboratory. Whether you want to do it or not, that's left up to you. Whether you want to just take a degree and go to the academic institutions, or you want to start a shop, or if you want to go to a manufacturing unit, that's up to you. But India needs your innovations as individual laboratories if you are talking about the use of AI in pharmaceutical sciences, nothing less. And your motto should be that we will take over China in terms of use of AI patents. Today, China is leading AI patents. If you see last 2-3 days, if you are reading media, international media, US is worried about how China is taking over AI in various fields through small changes here and there. They are also fearing that some of the technologies are stolen by China. Nowadays, everything is possible to pick it up and develop something on that. India, being what it is, very vast country. We have got legacy of 5,000s of culture, very innovative minds, and probably during the British era, we could not innovate ourselves. We were subjugated. We were almost like slaves. But now you are free, and I think this is the time that you must think about taking the world, take on the world, and spread across. AI technology is going to provide you that, and AI technology is also going to be a tool to make you the superpower, economic superpower of the world. I think I must end here, and I wish the conference a grand success and hope some of you become the experts and the holders of patents that even China and USA would also be like they should feel helpless in front of you. Thank you very much.
Thank you, sir. India, as the pharmacy of the world, indeed has immense potential which can impactfully increase GDP of this country, and by harnessing the power of AI, it can be possible. Thank you so much, sir, for taking the time to be with us and for sharing your knowledge and experiences with us. As we draw the inaugural session of this conference to a close, I would like to take a moment to express our sincere gratitude to all those who have made it a resounding success. Firstly, I would like to extend our heartfelt thanks to our keynote speaker, Mr. Mahesh Zagade sir, for his enlightening session. Your extensive experience, visionary insights, and commitment to the public service have given us much to reflect upon. Thank you once again, sir. Our sincere thanks to our Honorable Vice President, Dr. Rohit Tirak sir, for his motivation throughout this event. Your vision for the institution continues to propel us towards the greater heights. A special thank you to our Honorable Director, Dr. Pranati Tirak ma'am, whose efforts and mentorship have been integral to the smooth functioning and success of this conference. Sincere thanks to respected Secretary TMV, Mr. Ajit Khadilkar sir, for his cooperation and support. I express our gratitude to Registrar LTIPS, Dr. Meera Deshmukh, for her unwavering support in making the conference possible. I would also like to express our deep appreciation to our Principal LTIPS, Dr. Meenakshi Devdar, for her consistent leadership and support. Lastly, I would like to thank all of you, the attendees, participants, and speakers, for your active engagement and valuable contributions throughout this session. Thank you all once again. Without a further ado, we will begin with the technical session of this 2 days national conference. Over to Apurva ma'am.
I hope I'm in time.
Thank you, ma'am. On behalf of everyone present here, I would like to extend a heartfelt gratitude to Dr. Patravade ma'am for her insightful presentation on nanotechnology in healthcare.
And someone. Tell me if I'm audible, please.
Yes, ma'am. Okay, the session is open for question and answer series. Any questions?
Anyone has questions, please come near the computer and ask so that I can hear.
Yes, ma'am, we have one question.
So you did study on the Alzheimer disease, and so like glycon base will be used for the increasing density. So apart from that, can you elaborate something more on that particular formulation, VPP? Apart from that, any other molecule which we can actually use in Alzheimer disease, similar to a VPTN.
So basically what I would suggest is, look at Indian wealth. Wealth of India volumes I hope you have in all the libraries. Look at Wealth of India, right? These are time-proved remedies, but they have not been explored in a modern way. So you can select, like Brahmi, right? Brahmi, for example,
Yes.
it increases our memory. So why not work in a very systematic way and give it a modern dosage form so that people can take it? No one wants to take extracts nowadays. No one wants to drink those, smelly extracts. So give it a modern form and then use. So using, of course, AI, you can do the study, so you know what is the active in Brahmi, right? And that Brahmi you can block and go in the same way and as what I have done the studies and come up with this particular formulation. So I think I can give you that lead. Another lead which glycos which I had used was in case of vaccine, not for Alzheimer, okay? Glycos, why I had used glycos? Because I wanted to know which is that particular solvent which can give good hydrogen bonding with my polymer. And if it gives me good hydrogen bonding, that means it gives me high viscosity, right? So
Yes.
that type of study easily can be done using Material Studio and other platforms which we have, right? So even solubility studies nowadays you don't have to do in the lab. We also do solubility studies using these computational things which we are available to us, right? So you do initial screening and then you go and whatever screen out the excipients and then see whether your results are same as what computational mode had given. So that also can be done.
Yeah, thank you so much, ma'am.
Good afternoon, ma'am. My question is, are there any new biodegradable nanoparticles in research?
So, see, biodegradable, if you say people started using PLA, polylactic acid, right, polyglycolic acid, PLGA. Then they went on to polycyanoacrylates. Then cyanoacrylates are good, they are very good adhesive. But you know that finally they are cyanoacrylates. So, some monomers, if they are released over a period of time, they'll be really toxic. People have also used on polyepsilon caprolactone, so they are also biodegradable. So this is all about your synthetic polymers. What I am trying to imbibe into you students population is, why can't you look at something which is in our natural surrounding? All of you as kids have played, right? You would have seen many things which have given you very sticky exudates from the tree, isn't it? Chiku tree, for example, right? Whether that can be converted into a biodegradable polymer, that will become definitely new.
Yes.
Like we selected these xyloglucans, right? They are also biodegradable. What are they? They are coming from tamarind seed polysaccharide. Tamarind seed is a waste material. So look at such sources, which are waste materials from where you can generate wealth. I hope I answered your question.
Yes, ma'am. Thank you.
So this idea of Chiku, I had given it to one college and they started working on okra. You know what is okra, right? Bindi. That also gives you mucilaginous mass, which is mucoadhesive, isn't it? All these are biodegradable polymers.
Hello, very good afternoon, ma'am. Myself Arman. I am from Baramati. So my second question is regarding the AD. I mean Alzheimer disease. So, ma'am, nowadays we can say only respiratory diseases into the intranasal spray, only relaxing the disease or treatment. But I asked the question for the Alzheimer disease into the intranasal spray. That is the permanent treatment or only for the relaxing treatment?
No, it will be a permanent treatment. Basically, what we are trying to say, when you are giving through a nasal route, there is one mechanism that we have in our olfactory area. Olfactory area is the highest area under the nose. We have axonal transport, so you don't have any BBB there. From nose, directly the formulation enters brain. Okay? So we are avoiding BBB. Which other ways, if you are taking oral, most of material gets wasted in liver. If you give it by IV route, it goes to liver, spleen. Because anything which goes in the body is taken as a foreign material, right? So it is being eaten up. Especially the nanoparticles would be taken by liver. So if you give it by nose, most of the active is going to the brain. So obviously, if the condition can be stalled, it cannot, meaning in our case with BPPN, we have seen that it is reversing, right? If it is reversing, you are going back to your normal state. But even if it can be stalled, memory will not further deteriorate.
Okay, thank you, ma'am.
Ma'am, it was an honor being in your session. Thank you so much. But my question was, can nanoparticles reduce the side effects of the medicines?
Answer is yes, because when we are making nanoparticles, we have seen that its dose decreases 1/10th, 1/20th. In one case, we have got one drug, which Glaxo had sort of withdrawn, but we reduced the dose to 1/50th. So at the dose at which Glaxo had introduced, it gave cardiotoxicity, but by making nano, we made the dose 50 times lower. At that dose, there was no cardiotoxicity. So because you are reducing the dose, definitely the side effects either can be reduced or they can be over.
Okay, thank you so much, ma'am.
Ma'am, as you stated, there are advantages of using the nanotechnology. So, are there any Indian companies that are making the nanotechnology-based medicines? And if they are making, so what is the average cost of formulation?
So answer again is yes. For example, we made curcumin nano systems which are in encapsulated capsules, which are being sold in all cancer hospitals as supplement. Okay, so those are soft-gelatin capsules already in the market. Vitamin D, which I had shown you on the last slide, vitamin D3, it's in the nano form. They are not very expensive, let me tell you. Because why they are not expensive? Because the technologies which we are using are beaker technology. Why I am calling them beaker technology? In the lab you can do it in beaker. And when I am doing it at large scale, I need only one mixer. So if you keep technology that simple, cost doesn't increase. But yes, if you want to now, for example, you want to tag, I told you we are working on antibody conjugated nano carriers for anti-cancer. So first, antibodies are expensive. Then you are doing conjugation, a chemical process comes in, then you are making nano carriers, they need to be lyophilized. So at each step the cost goes on increasing. Having said that, for certain diseases where there is no answer, for example pancreatic cancer, no answer, lung cancer, no answer. When there is no answer, something is better than nothing, right? So start in this way and then see that you can decrease the cost.
Thank you.
So cost depends on for what the therapy is intended. Companies, if you want to know companies, yes, Sun Pharma is making it, Cadila Pharma is making it, all major, Dr. Reddy's is making, all top major Indian companies are making that.
Again, hello ma'am, this is Faisal. Can you elaborate the amyloid beta fibril mechanism in causing Alzheimer's disease?
The test which we have done or A beta? So the
No,
test
ma'am.
which we have done, is that you have A beta fibrils which get generated when you have memory related issues, right? These A beta fibrils, they react with thioflavin T to give fluorescence. If your moiety has anti-Alzheimer effect, it will break down those A beta fibrils. So if it breaks down, the fluorescent intensity which you get is much lower and sometimes it is nil. Okay? So A beta plaque formation leads to basically, I would say, losing the elasticity of your blood vessels over a period of time. Because of which there is no proper circulation, because of which you have memory related issues.
Okay ma'am, got it. Thank you.
Good afternoon, ma'am. My question is, what is the role of lipids, nanoparticles in COVID-19 vaccines?
In
COVID-19 vaccine.
very good question. So you know that COVID vaccine which came actually from US was mRNA vaccine, right? So that was based on lipid nanoparticles, and idea is, as I told you, they are looking at something which can be a non-viral vector. For a particular virus to be delivered, why use another virus? So use non-virus. So now viruses are small. They are in nanometric range. So can you look at virus-like particles which are also nanometric in range? And here came lipid nanoparticles which are in nanometric size, which gives you adequate presentation to APCs. APCs are antigen presenting cells. So in the nasal passage, you have antigen presenting cells. So when your mRNA was loaded into these nanoparticles, lipid nanoparticles, or in our case, for example, when it was loaded into, say, xyloglucan, we loaded spike protein into xyloglucan, right? So it presented it to antigen presenting cells in much higher concentration. So once that happens, meaning it is able to go through your nasal epithelial membrane, that means it is able to generate immunity, it generates response, right? In addition to this antigen entering, it generates response. And that is what I showed you in my slides, right? So in COVID vaccine also, lipid nanoparticles behave the same way. It presented it well to antigen presenting cells, because of which you got the response which you saw in case of COVID vaccine. But all of you would have taken probably vaccine subcutaneous or intradermal vaccine. Later on nasal came into much. Imagine if nasal was available earlier, no one would have had to go to any hospitals. There is a fear always, right? We might get infected rather than get protected. Because someone might be having some kind of infectious disease, maybe COVID itself. COVID period also many people had already COVID when they came to take COVID vaccine.
Thank you, ma'am. Your expertise and perspective have truly enriched our understanding of how nanotechnology is shaping the future of healthcare. Especially the case studies which you have discussed here are truly commendable. Thank you for elaborating the information on brucellosis, rapid detection kit, COVID non-invasive vaccine, and coronary stents. Innovations like this we need to look up to, which will truly have its industrial applications. Today, we had an opportunity to hear your thoughts, and this will surely be going to encourage us in our future events. Thank you once again, ma'am.
Thank you. Can I log off, please?
Yes, ma'am.
Thank you.
Thank you, ma'am.
Everyone.
Thank you, ma'am. As we are about to start with the next session, now I request our dignitaries to take their seats on the dais. Please, ma'am. Please, sir. Advancements in oncology research are transforming the way we understand, diagnose, and treat cancer. From breakthrough therapies and precision medicine to immunotherapy and early detection techniques, ongoing research continues to improve patient outcomes and quality of life. Staying updated with these developments is crucial for healthcare professionals, researchers, and patients alike. In this session, we will explore recent updates on research in oncology. We have with us today our next speaker, respected Dr. Sriram Inamdar, Director, Clinical Operations Xylem Research LLP Pune, to guide us on the same. Now, I request Principal LTIPS, Dr. Meenakshi Devdhar ma'am, to welcome Dr. Inamdar sir. Please, ma'am. Thank you so much, ma'am. Thank you, sir. On behalf of LTIPS, I am elated to introduce our next speaker. Dr. Inamdar brings over 25 years of experience in oncology, clinical practice, and 22 years in clinical research. He has managed more than 300 global clinical trials across various therapeutic areas with a primary focus on oncology, along with the expertise in cardiology, general medicine, psychiatry, surgery, dermatology, and more. With a strong background in clinical operations and business development, he has played a key role in coordinating both internal and external audits. Dr. Inamdar has been instrumental in identifying and developing numerous high-quality investigator sites for clinical research and creating innovative strategies for enhanced patient recruitment. He is actively involved in writing articles on clinical research for regional newspaper and collaborates with research and non-profit organizations. His research has received widespread recognition from leading national and global research organizations. Dr. Inamdar is skilled in setting up clinical research departments for emerging hospitals. He is currently serving as integrated cancer specialist in Pune, where he provides cancer treatment, offering counseling to patients and their families on the best treatment options and assisting with treatment costs through reputed NGOs. Let's hear it from Dr. Inamdar sir on topic recent updates on research in oncology. Please sir.
सर्वप्रथम सर्व टीमवीच्या मान्यवरांना माझे मनपूर्वक आभार. देवदर मॅडम आणि सगळ्यांनी मला आज या ठिकाणी हा जो काही येऊन तुमच्यासमोर कॅन्सर अवेअरनेस आणि रिसर्चच्याबद्दल जे काही बोलायला सांगितलं आहे त्याबद्दल त्यांच्या सगळ्यांचे आभार. मी जसं इंटिग्रेटरमध्ये काम करतो तसं आय एम ओके ना भाई, मराठी इंग्लिश चालेल ना? हां, तर त्याप्रमाणे मी इंटिग्रेटर माझं प्रेझेंटेशन आज आहे. इट इज बिकॉज ऑफ जे काय लाईफस्टाईलमध्ये आत्ता आपल्या गोष्टी आहेत मॉडिफाईड आहेत त्यावर थोडंसं बोलणार आहे मी, इन्क्लुडिंग ॲलोपॅथी, आयुर्वेद आणि रिसर्च कंबाईनिंग. नेक्स्ट स्लाईड. नेक्स्ट स्लाईड. आय वर्क विथ लाख फाउंडेशन, सो दॅट्स वाय माय स्लाईड इज देअर. नेक्स्ट स्लाईड. सो बेसिकली आत्ता रिसेंटली पुढच्या आठवड्यामध्ये वर्ल्ड कॅन्सर डे आहे 4 फेब्रुवारीला. So basically it's an international day marked on 4 Feb to raise awareness of cancer. So त्याच्याबद्दल आता आमचे खूप कॅन्सरबद्दलचे काही अवेअरनेस टॉक्स आहेत, कॅम्प्स आहेत, लेक्चर्स आहेत. तर बेसिकली टू एनकरेज प्रिव्हेन्शन, डिटेक्शन अँड ट्रीटमेंट हा 4 फेब्रुवारीचा जो दिवस आहे हा इज लीड बाय द युनियन फॉर इंटरनॅशनल कॅन्सर कंट्रोल टू सपोर्ट द गोल्स ऑफ वर्ल्ड कॅन्सर डिटेक्शन. हे 2008मध्ये लॉन्च केलं होतं. नेक्स्ट स्लाइड. सो कॅन्सर अँड कॅन्सर प्रिव्हेन्शन, व्हॉट यू नीड टू नो. नेक्स्ट. बेसिकली कॅन्सर इन इंडिया, in 1 to 2 million new cases detected every year. 3 to 3.5 lakhs died each year due to cancer. Out of that, 500% increase in cancer in India by 2025, and now it's going to be again more because of cancers and other factors which they are getting. What is cancer basically? So loss of normal growth of cells control, basically normal divisions and cancer cell division. You can see the slide. The mutations are there and how they go, and uncontrolled growth of any cells which is got abnormal cells, and then body gets cancer. Next. Different kinds of cancers are there like leukemia, breast stem, lymphomas, colon cancer, bladder cancer, lung cancer, breast cancer. Basically, some people always get fears if they got lump in body or in गाठ असते माझ्या अंगावर कुठे काही, तर कॅन्सरची गाठ आहे का. तर there are 2 types of benign and cancers, malignant. Some lumps are already benign. We have to find out exactly what is their structures and what is their size and all. So benign is not cancer. Tumor cells grow only locally and cannot be like a paid invasion. But cancer cells are increased, they growth inside the body cells until they get affected by any other organs. People won't know that this is a tumors growing inside the body. That's why we are saying people to come forward for screening. Next. Why cancer is potentially dangerous? Because they affect brain, they affect lung, livers, they affect all kinds of melanomas. Next. What causes cancer basically? Like some viruses or bacteria, some chemicals, radiations, and hereditary diet, hormones, and again now I can say lifestyle. Whatever lifestyles we are now adopted, it is again main cause of cancer. See, now I will just correlate between Ayurveda and allopathy. So in ancient science, people used to take just straight नाडी परीक्षा. पूर्वी नाडी परीक्षा व्हायची आणि लोक त्याच्यावरती आधार सांगायचे. तेव्हा काहीच एक्सरे, स्कॅन, पेट स्कॅन काही नव्हतं. आज तुम्ही गेले डॉक्टर लाईक पेट स्कॅन घ्या, लॅब घ्या, हे सगळं घ्या. पण पूर्वी काय होतं, दे विल जस्ट चेक युअर बॉडी, appearance of the disease, appearance of tumor, and then they will diagnosis. पुढे. So basically, life Veda is science. Like life science, Ayurveda is a Ayurveda basically. Next slide. So what is health? The health is a state of physical, mental, social, and spiritual well-being. So health should be balanced. Next. Dosha like biological elements. Dhatus like tissues. The doshas are all are Ayurvedic concepts, Ayurvedic words, you might know it. And the other part is allopathic concept. Right? The dosha is like biological elements, dhatus, tissues, agni is metabolic fire, mala is estates, and happiness or crimes like mana, mental health, indriya like sensory, and atma is spiritual. So Ayurveda and allopathy you can just say it's combination, and the word which is in Ayurveda is right now following allopathy in this way. So in Ayurveda there are prakruti like pitta, vata, kapha, vata, pitta, kapha. It's a constitution basically. The Ayurvedic consultant check any patient, they take prakruti and they give treatment. So these Pancha Mahabhutas are there. Akash is space, Vayu is air, Agni is fire, Jala is water, and Prithvi is earth. Entire this is in our body, and this allopathy and Ayurveda is same name. Next. Dhatu like Saptatu are there in Ayurveda, Rasarakta, Mausa, Veda, Asti, Maja, Shakura. And same you can say in allopathy like plasma, blood, muscles, Meda is adipose, Asti is bone, Maja is marrow, and Shukra is reproductive system, tissues and all. These 7 dhatus are considered equivalent to pathology in view of modern Western medicine allopathy. So status quantification like by study of pathology, by study of body blood, data habits, etc. By study of radial pulse, like I said, Nali prediction. By study of time, examination of urine and other excretions from human body, and above all, a classical methods of the status of quantification are the basic fundamental of the Ayurveda, the Indian system of medicine. And nowadays, allopathy people are giving all this blood sample, urine sample, X-rays, CT scans, and all. So how does the cell loads control? Like oncogenes, they are always on. They will not any stop. And the tumor suppression genes are disabled. So when any kind of tissue is not affected by cancer cell, these oncogenes are getting on and they start spreading the body. So radio of the next. The ratio of doctors in India. So telling most common male cancers, lung, esophagus, leukemia, mucosa like buccal mucosa, mouth cancer, pariform fossa again, mouth, base of tongue, mouth cancer, lymphomas, larynx, stomach, and anterior tongue breast cancer again. In female, breast cancer, cervix, ovaries, esophagus, leukemia, lung, and other things. Next. So framework piece basically is what of cancer treatment. What comes under the entire treatment? This is the slide, you can just see entire things are there, right? First part I had prevention. So I always talk about prevention. Cancer होच नाही म्हणून पुढे काय करतात? बरेच लोक आहेत की they come after diagnosis cancer. But my work starts before that. I was talking people that you come forward, have an adequate lifestyle where you will not get any disease. Forget about cancer. There are a lot of diseases like diabetes, hypertension, thyroid and all. They all are lifestyle diseases. So what to do? So prevention part. So for what you have to personalize things, like what you are doing in your lifestyle, you have to modify it. So that comes prevention. Then part comes diagnosis. What diagnosis is there? Then pre-treatment, then treatment. Then in treatment there are two options. Once patient got cured, it go under rehabilitation. So what life after cancer? What they should follow lifestyle, what they should do. त्यांनी आधी काय केलेलं आहे त्यांच्या लाईफमध्ये ते त्यांनी पूर्ण करू नये. So that cancer will prevent, relapse will prevent. So that comes to rehabilitation. Palliation means what? Basically the patients sometimes they come after stage 3 or stage 4. So we really don't want to don't get cured of them. Stage 1, stage 2 cancers are really we can control, they can cure. But stage 3, stage 4, they come with mets, lung mets, liver mets and all. So we don't get cured, we can control for some time. So that patient goes into palliation. Sometimes you have to leave their hopes of patient's life. So they go into palliation. What palliation? Basically the patient's life, whatever life is there, that should be peaceful of life. Pain control, painless life should be there. So that goes into palliation. Then next part is come survival. Like these all patients, they live the life till their whatever life is there available. That should be a good quality life. So in that survival part, we have survival meeting also. We call these patients together. They can talk to each other. They can share their problems with each other, and then they get continue with that support group and they live their life. So this come under that, and this is the entire framework. So early cancer may not have any symptoms, like I said, a lump in breast, lump in body, which is growing, which is not hurting. It could be cancer. It could not be cancer, but you have to come forward for testing. So 7 warning signals of cancer. What it is basically? Change in bowel or bladder habits, a lump or thickening in the breast, unusual bleeding or discharge from nose, from anus, from like type of menstruation cycles and all, persistent indigestion or difficulty in swallowing, an obvious change in a wart or a mole, a nagging cough or hoarseness. Some medicines are given, but each cough is not going. 7 days, 8 days, 10 days, people are not having any symptom relief with the medicine. Definitely it should be allowing to come and check further. And non-healing ulcer in the mouth or tongue or anywhere in the body, which is also one more sign of cancer. These are major signs of 7 warning signals. So various forms of smokeless tobacco, like all these things. This is a pre-malignant lesion of the oral cavity. Many of these youngsters, people and ladies also nowadays, they get chewable tobacco, mishri, gutka. So these kind of white patches come in their mouth inside. So it is pre-cancerous, but if they continue the same habits, they will definitely diagnose cancer in future. This is a young boy, 22-year-old boy. His gutka is using for 10 years and he developed cancer. Not able to open mouth. So multimodal treatment approaches in cancer like surgery, radiation therapy, chemotherapy are there. The role of personal medicine, like I said, the Prakruti. In Ayurveda, initially people used to take Prakruti, they used to check their nadi condition and they give medicine per person. Every patient will get different medicine in Ayurveda. प्रत्येकाला वेगळं औषध असतं. असं नसतं की औषध किलो घेतली तर आपण दिली मग. So Ayurvedic concept वेगळी आहे. तसं आता allopathy people have started doing. Basically, improve tumor control and survival. Benefit of observing all clinical studies, post-op, definitive and operative patients, using personalized medicine, targeted therapies. You might heard, like MAB, monoclonal antibody, heart safety, trastuzumab, pertuzumab, bevacizumab, durvalumab, nivolumab. All these are MAB terms nowadays in lung cancer, breast cancer. So a lot of patients, stage 3 or 4 also now getting good results, and we are seeing patients recover from the cancer. But of course, these are very expensive medicines, very expensive treatment, and for this purpose, we have to check genetic panel, NGS, next sequence genetic panel for every patient. And in that patient, suppose they found PD positive, they found some testing positive, MSI high, and all kind of things, then we are giving the different medicines for that. So again, what I was saying, this initial Ayurvedic people was doing that same testing, Prakruti. Nowadays, again, we are going towards that same stream, personalized medicine. So breast cancer next. Again, began in fibromyalgia and all this. Being woman, first this risk for breast cancer is basically every woman after stage 40 should have done a mammography or checking by the physician, oncophysician. 2/3 of the breast cancer are diagnosed in women over 50. But nowadays that 50 is again come down to 35 to 40. We are seeing people like patient 30 years, 25 years also in our OPD. So what do you must know about your breast? Like sexual characteristics, development, puberty, milk production glands, visibility around shape basically, dark globules and all. These are the best. Next. So breast cancer incidence in India, urban is 1:22, rural 1:66 women, and western is now 1:8. 1 in 8 women get breast cancer nowadays. So breast cancer growth of abnormal cells, reproduct and divide, develop, control usually being ducts मध्ये असतात ते breast cancer spread to lymph nodes in axilla. They get spread in axilla. So woman can check their breast and find the axilla also, and she found a lump in that axilla or breast, they can 100% come to meet oncologist. So breast cancer symptomless when they begin as first muted stage. Initially काहीच कळत नसते. It takes 5 to 10 years for symptomatic mass to be fed. खूप 2 वर्ष 3 वर्षापासून ते मास असतं ब्रेस्ट गाठ असते पण वुमनला कळत नसते बऱ्याच वेळा. When a mass is formed in beginning to spread or invade other part of the body. एकदा ती गाठ जर तयार झाली की मग ती spread or swallow होते. Pain comes only in the later stage. सुरुवातीला बघा असं म्हणावं लागते की काहीच पेन कळत नाही, पेनलेस. इनिशियली काहीच समजत नसतं की काय होतं प्रॉब्लेम. But recommended routine screening after age 30 or 40 detected a non-palpable lesions, a cluster of microcalcification or mutated cell. We have nowadays digital mammography and sonomammography. So very small lesion also can be picked up nowadays. No need to be wait for that kind of thing. So if you come for screening, definitely many people are in our OPDs and in our clinics. They come just for routine checkup. काही नाही हेल्थ चेक ला आले आमच्या कंपनीत जॉईन करायला नवीन ठिकाणी. So health check चे parameters आहेत. So we just come for health checkup and they found lump in the breast and which is cancerous. So don't wait for symptoms if you are age 40 and now I will say 35. And these are the again parameters where people also nowadays females also do smoking and all things. Next. This is basically one patient's photo. Next. The breast lump is there and it's spread in the axilla. These are symptoms include underarm. Don't miss them. If you have feel anything, any lump in the breast and the axilla, definitely come forward. Next. So as I said, 1.5 years to grow from size of this tumor takes 5 years to grow 1 centimeter, and then frequently once it diagnosed 90%, it will be too late. Initially it has to be very slow. 1 centimeter tumor get 2 to 3 to 4 years to develop that size. So early detection is very good for treatment and save life, and you can get cured 100%. So you can prevent it from spreading to other parts. So today advanced diagnosis is available and survival rate is almost 95%. The effect of tumor size on survival. See, if it is huge size of tumor, survival is small, you can see. And a small tumor, survival is large. This is a parameter. Again the staging I said. So this is a breast self-examination thing. Woman can check. Not like this. It should be a palm. You can come and doctors, they can teach you also. And the clinical examiner doctor. Both are the good testing models. Mammography, basically, after 40 of this age. Before 40 we don't do mammography. Because before 40 we do sonography of the breast. That ultrasound. And the biopsy we can just, if any lump in the breast we found. In mammography, we understand the birad of the node, size of birad 1, 2, 3, 4. So if it is birad 3 or 4, definitely which alarming thing. So we suggest to biopsy. Birad 1 and birad 2 is not cancerous. So that needle is there, small needle biopsy is there. Just one needle biopsy, and you can get report in 2 days time. And mammotome is there to suck that lumps in the breast. Next. Again, this is the side of how to do self-examination of the breast from children. Like you will stand near in front of mirror, and this is a way to do this. Yes. Mammogram is a special X-ray of breast with different angles. Detect abnormalities long before lump being fed. We cannot fed by hand, but mammography, as I said, and now too we have digital mammography. So it is really very super test where we can pick up very small kind of tumor in the body. Yes. This is actually a kind of test. This is the lump which seen in the mammography. It's a cancerous cell. Yes. Ultrasound. These are all the procedures, right? Which I explain now. Next. So multimodal cancer treatment is what? Like surgery, chemotherapy, radiotherapy, and now in chemotherapy, as I said, monoclonal antibodies, target therapies are added. So now in future, entire treatment will be completely changed and will be on personal basis. Every patient will undergo NGS, comprehensive genetic panel, whatever genes found in their tumors and all, they can treat it accordingly. Next. Next. This is basically cartwheel machine we have, where the patient gets cancer treatment and then they lose one side gap, which they lose hair. So there is one machine comes, cartwheeling machine. While doing treatment, they can put on their head and they will, basically there is hair loss but not much as was the earlier one. Next. So prevention can say basically like making changes within your control, monthly breast examination, annual examination by doctors, yearly mammogram after age 40, and maintain right body weight and exercise regularly. Next. So physical activity like 30-40 minutes daily, 4 times a week, can be on several parts, and kind of physical activity will count. Next. Next. So breast cancer treatment is scientific and sociological. We have detection, like I said, actual treatment, research, and sociological like awareness, volunteers, and advocacy. Like I said, we have survival group. So people go in society and all these places and they do awareness cancers treatment, and they can come forward for treatment, checkup and all. Next. So mass screening effect. Like we are doing screening, what we do? Females clinical breast gynec examination, mammography once in a 2 years, baseline at 40, 45, then after 50 once in a 2 years. Pap smear is there once in 3 years, after age 22, 55. Colposcopy with indicated if indicated. Ultrasound of pelvis, abdomen, and oral examination for females. For males, oral examination, digital rectal examination for prostate and PSA will be blood test, stool examination, colonoscopy, and X-ray test for smokers, and low dose of test. It is very low dose of test. Like in X-ray, people say we should not be exposed to X-rays radiation, but X-ray test is very low dose, there is no harm. So in general, what are the lifestyle changes they prevent cancer? So limit alcohol and tobacco. Next. Limit fats, calories. Next. Diet consume fruits and vegetables, and of course exercise. Industrial pollution, like you know that lot of industry things are there, so we get all pollution and all. That's why we get very bad chemicals, in around cities also. So in summary, cancer can be prevented by leading a moderate lifestyle and taking care of yourself. Listen to any changes in your body. Ask for a cancer screening package next time you get your cardiac testing. Remember, cancer is better to prevent than treat. It has to be early diagnosis, then only able to treat. If you come late, people really not get a good treatment. I have time. No? So I will just a little bit talk about research, like next one. So clinical trials is one more part which I also working on that part. And in cancer, lots of research is going on. So I'll just take little bit 3-4 slides on research. So clinical trials is an organized research conducted on human beings to investigate the safety and efficacy of a drug. These are step 1 like target selection step, step 2 is drug selection, and high throughput screening. Like if I am a doctor, I want to do some research on lung cancer. So I will thought first molecules in my mind, then that drug should be coming in my mind, and then afterwards we start working on that part. So it's phase 1, phase 2, phase 3, phase 4 trials. You might know all these things. Next. Next. So this is basically one more major slide. Like new drug development journey. It's a very long journey. Like compound success rates by stage. 5,000 to 10,000 molecules we are screened. Out of that, 250 enter in preclinical stage. Out of that, 5 only enter further, and 1 approved by FDA or DCGI. So it takes 12 to 15 years and almost $800 to $1,000 million to be on new drug market. So these much of things before any drug come in the market. These are the parameters are there. Any drug if you come in the market today, so you see this drug research started 15 years back. Okay. So regulatory framework like ICGCP, local regulatory guidelines, DCGI, ICMR, local ethics committees. Next. Next. So research conduct, why GCP basically? Good clinical practice, why? Because research conducted at one site, but it will be studied data is globally. If you are doing study in Pune, after study publication, the data will be used and the drug will be used by entire world. So that's why there should be guideline, which should parameter, same parameter, and everybody should follow same rules and regulation. So these are the guidelines, 97 ICGCP guideline, good clinical practice 2001, like that 6, 7, 12, 13, and recently guidance for good clinical practice system in 6 January 25. It's recently just, they are updating every time. So who does like GCPs follow? The sponsors, the one who's funding the trials, drugs, CRO who working on the trials, and doctors, sites, and its committee and all. These are the 3 pillars like next. 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 So basically all these regulators should follow this entire GCP, quality of the work, quality trials, and documentation part should be the good way. Pharma companies, biotechnology companies, contract research organizations like CROs, research academic institutes, and cooperative groups. There are groups also there, they are come in one group and they are do trials and all. Like earlier speaker said nanoparticle, so we also work on nanoparticle trials. Curcumin, हळदीचं जे आहे त्याच्यावरती आपण काम केलेले. डॉक्टर माशेलकरांनी आपल्याकडे ते पेटंट घेतलं होतं. इट वॉज नाउ दिस US wanted to put as a patent, but माशेलकर सरांनी ते एफर्ट घेऊन ते पुन्हा इंडियाकडे आले पेटंट. So we work on that nanoparticle trials of curcumin also. Schedule by Drug and Cosmetic Act 1940 started that time. Next. So basically, next. Next. So be healthy by choice, not by chance, basically. So like I said, do exercise, do your lifestyle modification properly. आपल्याला माहिती पाहिजे की आपल्याला काय होते आणि कशाने होते. त्या गोष्टी आपण जर टाळल्या, व्यवस्थित जर आपण आहार विहार केला, जसं पूर्वी सांगत होते. ऋतुचर्या, दिनचर्या, पूर्वीच्या काळात किंवा आता सकाळी पहाटे उठायचं, सगळे जे काही प्रत्येक ऋतूमध्ये प्रत्येक काळात काय काय तुमचे कपडे सुद्धा कसे घालायचे उन्हाळ्यात, पावसाळ्यात, हिवाळ्यात हे सांगितले गुरु ग्रंथामध्ये. So if we do that way, definitely you'll be healthy and wealthy. Thank you very much. Any question about research and answer also, whatever I am.
Hello sir, I am from Kashibai Nole College of Pharmacy. Do you conduct some camps in the college?
Yes, madam.
For prevention?
Yes. Definitely. As I said, we come to colleges, schools, we maximum start awareness camps and all in the schools only. Because these kids are there, they can go and talk to their parents. If suppose their father is going to smoke and all, these kids, we have done it earlier. Lot of colleges and schools we go and do camping. And awareness talk for these cancers.
Thank you sir. Yes, I will contact you sir.
Yes, sir.
Hello sir.
Yeah.
Myself Shubham More. I'm from Lokmanya Tilak Institute of Pharmaceutical Sciences. So my question is, sir, everyone knows that there are some diagnostic testing for the cancer like PET scanning, biopsy, mammography,
right,
NGS also. So these all the tests are too much costly and time consuming.
Yes.
So my question is, could we apply artificial intelligence in diagnostic to reduce the cost and time?
Yeah, it is nowadays like coming up AIs, but see again AI what it will do once we teach that person like that things, then we able to do this is the testing. But whatever time is required to do the testing of the biological cells and all, it is required. If suppose we do biopsy, it has to be cutting, it has to be make slides, and then doctor can see in the scope. That time is there. That much time is required. Again, NGS test required 2 to 3 weeks. Same parameters, like they will separate the tumor cells, they will separate it from them, they will test it, and then they will be able to give results. So it will be same, only AI will do little bit faster than the human, otherwise same thing. They will work 24 hours maybe, but time may be reduced 3-4 days or 1 week maximum, not more than that. It's under process nowadays, not as confirmed.
Thank you, sir.
Thank you, sir, for the informative lecture. I have one question. Actually, nowadays a lot of research has been going on placental extracts and stem cells in
Yes.
cytotoxicity.
Yes.
So, how is it practical for use in near future, and what will be the challenges associated with such kind of drug delivery?
See, basically nowadays the preservation of placenta and all are going on, but again, I have not heard it is 10 years back or 20 years back in placenta is preserved and that is used. But of course, there are some cancers like blood cancers, the stem transfer and all. That time it is very useful for this patient. 1 or 2 cases I heard that they have preserved 20 years back placenta and the person diagnosed cancer, blood cancer, and that stem cells now that transfer and that got good results for their treatment. But there is no harm, definitely it is good because we don't know after 10 years what will come out. Like COVID, we never thought about COVID, we never thought about swine flu, but it's going on. So it's googly, we don't know anything what will happen. Whatever system and whatever we get new things, of course there is a rebonding happening, going to be happening. That you are seeing in a couple of years.
Thank you, sir. Thank you, sir.
Sir, are there any devices which are invented to predict or to identify tumor cells?
Tumor
Or
cells.
cancers in
See,
early
there
stage?
is some devices now in again research thing going on. When they have technique device which is being handy, they can put in the breast. One light is there, and the cancer like love what we see in the mammography and sonography that can be treated. But again, it's under process going on. It's not confirmatory. But yes, the devices are there.
Thank you, sir.
Thank you so much, sir. On behalf of all the attendees, I would like to express our sincere gratitude to Dr. Inamdar sir for delivering such an informative presentation on recent updates on research in oncology. Your expertise in this evolving field has provided us with a deeper understanding of how precise approaches can revolutionize cancer treatment, and we truly appreciate your time and effort in sharing these valuable insights with us. With this, I request our respected Registrar LTIPS, Dr. Meera Deshmukh ma'am, to felicitate Dr. Inamdar sir as a token of appreciation. Please, ma'am. Thank you, ma'am. Thank you, sir. Thank you once again for inspiring us and offering a glimpse into future of oncology care. Ladies and gentlemen, thank you for being a part of this remarkable event. Let us take a break of sumptuous lunch arranged at P2 premises C Wing. We'll assemble back sharp at 2:30 p.m. Thank you. Thank you once again.
Of ancient wisdom and cutting-edge science today, traditional knowledge passed down through generations has long been the foundation of many herbal remedies. However, modern pharmacology, with its sophisticated research and technological tools, has provided new opportunities to enhance and validate these age-old therapies. By integrating the benefits of both, we are opening doors to safer, more effective herbal medicines that are scientifically backed. This unique collaboration between tradition and innovation is paving the way for herbal drugs to address a wide range of health concerns. To introduce to us the concept of exciting developments at the intersection of herbal medicine and modern pharmacology, and how they could hold the potential to revolutionize healthcare worldwide, we have Dr. Prasad Thakur Desai sir, CSO of Indus Biotech Private Limited, Pune, to deliver a speech on innovations in herbal drug development. I request respected Principal LTIPS, Dr. Devdhar ma'am, to welcome Dr. Thakur Desai sir with a bouquet. Thank you, ma'am. Thank you, sir. It is my great honor to introduce to you today's esteemed speaker, Dr. Prasad Thakur Desai, sir. Sir currently holds the position of Chief Scientific Officer, CSO, at Indus Biotech Limited. With over 7 years at the company, he has been at the forefront of scientific innovation in toxicology, quality assurance, and regulatory affairs, playing a key role in developing and advancing nutraceuticals, dietary supplements, and complementary medicine. Sir has spent nearly a decade as General Manager Scientific at Indus Biotech Private Limited, excelling in areas such as project management, scientific writing, and clinical research. Sir is no stranger to academia either, having served as faculty at Birla Institute of Technology and Science, Pilani, where he taught courses in human physiology and pharmacology and mentored future scientists for over 4 years. He also served as an assistant professor at Pune College of Pharmacy, where he imparted his knowledge in human physiology and contributed significantly to academic research and publications. With a PhD in pharmaceutical sciences from UDPS Nagpur, specializing in pharmacology and toxicology, Sir has a deep understanding of the scientific underpinnings of health and disease and has published numerous articles advancing the fields of drug discovery, clinical development, and biotechnology. He also has a strong commitment to community outreach, reflecting his passion for both education and societal well-being. He also incorporates the additional areas of expertise such as toxicology, quality assurance, regulatory affairs, and scientific writing. Please join me in welcoming Dr. Prasad Thakur Desai Sir as he is with us to share his invaluable thoughts and experiences today. Please, sir.
Meanwhile, this preparation is going on, so we can start discussion. So today I have a difficult task in front of me to keep you awake after a very good meal which we just had in a lunch. And I can see a lot of students, and I am very happy that I am talking with students, and after the lecture you can ask as many questions as possible. And after the lecture also we can discuss personally also if it is there any question or queries or any discussion we can make. You can hear me? Last row? No problem? Okay. Okay. Okay, thank you. So this is what you can have full screen, if Control L. You do Control L. Yes, thank you. So you should know the technology also, to how to make it possible, because this is PDF. Okay. So this is overall the pathway. As I told you, with respect to natural product, you have more opportunities, but you should know how to deal with that and how to take advantage of that. So if you see that this graph will show increasing complexity versus increasing value. Value in terms of business, of course. So if you want to make value-added products to the food, which we everybody have, for example, what we work on is a fenugreek seed. Everybody of us use methi seeds. Even leaves also we use, but methi seeds are more used for our Indian food preparations, but very small quantity, for a number of reasons. And all of us know that some people use that as a medicine also. So that from food, if you want to get some more product out of it, you cannot sell fenugreek seed in the market like Amazon. Of course, anything is sold in Amazon, but you will not get value. So you can make slightly more better product, which is called as functional food. So we have one functional food where we have minimum processing to the product, but we removed the bitterness of the fenugreek, which will make it more amenable for the people, and which will not increase the cost that much, but it will give a lot of other benefits. That is another product which I will tell you sometimes in the presentation. Then if you go to the extraction level, like we are pharmacists here, everybody of us know what is extraction. So if you know the bioactive, and if you have selective bioactive from the fenugreek seed extract, which we did, for example, fenugreek seed contain alkaloid, glycoside, amino acids, and many other things. So if we have products as a standardized extracts. So that means they have specific biological properties or medicinal properties. For example, amino acid 4-hydroxyisoleucine is present in fenugreek seed, which is basically responsible for anti-diabetic activity. So if you know how much is the dose, we can make a dietary supplement out of it, which is basically standardized extract based on 4-hydroxyisoleucine. Of course, we have that product also. Then, if you go ahead with one more step, that you do some preclinical trials, clinical studies, toxicology, as per drug guideline, mostly, with a very stringent norms, good clinical practice, or FDA rules. You can sell that product as an Ayurvedic medicine in India. Of course, for this Ayurvedic medicine, this is also not required, but if you are having that, you are more confident on your product, and it is tested with the evidences. So it is an evidence-based product. In Ayurvedic category in India, you can do it. Now what I am trying to tell you is what is available in India, but I will tell you about global also. In a very parallel manner, you can do in global sense also. There are categories are called differently. There are minor differences between the requirements, but you can do it. The next category of product is if your product is specific for certain metabolic condition which can be changed, you can develop a medical food with health claims. Again, you have to go for dietary for the health claim, you need to have proper clinical trial, and from that medical food part, it is a purview of FDA. Before that, FDA will not interfere in your sale and marketing, but after that, you need to take permission of FDA with naturally with a lot of documents, dossiers, which is very parallel to the synthetic medicine, which has some certain small concessions, but there are certain additional norms. So it is balanced. They are different, but it is almost as good as drug. Now we are going towards drug. So one more category is a botanical drug, and in India recently they added the category in Drug and Cosmetic Act called as phytopharmaceuticals. So if you can show in a phytopharmaceutical at least, and in a similar manner in botanical drug guide in US, is a specific to US, you can get marketing monopoly, or we can say license after the approval. It is an approved product. These products can be considered in an insurance like drugs, even though they are from natural product. All previous products, you won't get any health insurance or reimbursement for that. For other products, it is up to you. It is up to your risk. But after that, FDA will take responsibility. Insurance companies will get payment. So naturally, your requirements are higher. What I am trying to tell you is, you can charge more. They will be costly, but you have more confidence, more claims, more specific population you can sell. With a doctor's prescription you can sell. These last 2-3 products you can sell it through doctor's prescription. Previous products are without prescription. So these are some of the differences. So we should know what you want to produce first, before you start even research. Where you can do, up to what extent you can spend your money, because this will need time and this will need money. So if you have that type of things in your mind, that is the first step towards the development of the natural product. Next. So this is, I just divided these categories into prescription product and non-prescription product. This slide I am giving you global regulations. Like first one is a food, everybody knows, basically we are taking it for taste or smell or odor or fragrance or color. There are many, these are the sensory requirements. Dietary supplement, already I discussed with you. This dietary supplement, you cannot make a health claim. You cannot add anything on your label or any of your literature, anything related to disease. In fact, you have to write one sentence that this claim, whatever we are talking about here, they are not evaluated by FDA. And in that case also you cannot write diabetes or hypertension, these kind of words. So this is what cannot be used in the label. Complementary medicine, you can use this kind of labels, but again, in certain countries, you need to show correlation of your product with the traditional books. Somewhere that correlation has to be there. Completely new things, even though it is from natural product, directly you cannot claim. But you can claim disease claim in complementary medicine. This is a difference. So this is a complementary medicine category is there in Australia. TGA, they give this kind of, this is example I am giving, but most of the countries, they have parallel guidelines for each. Food, more serious is dietary supplement, still more serious is complementary medicine. This is non-prescription product. Now come to the prescription product. Although complementary medicine in Australia, there are both, either prescription or non-prescription. In Australia, it is called as a registered medicine. Although you can be natural or synthetic, but registered medicine is basically prescription product in Australia. Now, prescription product category is medical food, product with health claim, and as I told you, registered medicine in Australia. So these are different countries with the different names. Ultimately, these are basically related to food, but you can get some health claim. Remember, there is a disease claim is different, health claim is different. So this is health claim you can take. Disease claim generally it is possible, but nobody, no countries generally gives that type of claim. Practically not possible. Whereas botanical drug, US, you can take disease claim. In fact, first botanical drug was the approval was given on genital warts, and second botanical drug, which is oral, it is given to the HIV-induced diarrhea, which are very serious diseases. Because there was no drug on these conditions, US FDA in fact helped the companies to get it into market. This is very rare. In US it is possible, in US FDA. Sometime US FDA will help. They want drug to come, proper drug, safe drug, better drug to come to the market. So sometime it happens, but your category should be very, very unique. That is different. But otherwise, botanical drug also, there is a provision. In 2004, they got botanical drug guidelines in US FDA. And there are certain number of drugs which got the approval. Not very much, many, but there are possibilities. Yeah, please go to next slide. These are the, like as I told you, in India, parallel requirements. Dietary supplement, this is governed by FSSAI. Now here I would like to draw your attention to these first two categories. One is sports nutrition product and exercise physiology product. This is the place where India is having now a lot of market, but not much research is going on, in Indian universities at least. A lot of other universities they are doing research, particularly in Australia and the places where sports is a major thrust. But this is very interesting area to work with. We do a lot of work on that, and many of our leading products are in this category. Even in US they are available, and India also it is now available in Amazon. So this is one category where you want to increase the capacity of the body. You want to improve your living. You want to improve your health. It's a wellness, not exactly wellness, but it is much better health you wanted to achieve. You want to do better. You want to be more younger. This kind of things. So now in the world, these kind of things are going on because everybody realize that medicinal cost is very high. So only possibility is prevention. And this is a place where you can do prevention. And now this kind of drugs and research is also very good going on all over the world. It was there, but now it is gaining some more importance in the market also. Then functional food, which is basically special medical use, where like probiotic, prebiotic, this kind of products are also now in the rise in the world. Then Ayush product, because of the a lot of, particularly with respect to COVID, these products came into the light. Actually, Ayurvedic products always had a good possibility of healing the diseases instead of getting symptomatic relief. Some Ayurvedic product, particularly if they are used properly, I'm just giving this very important term, Ayurvedic product has to be properly made and properly given by the proper person. If the person is wrong, an Ayurvedic product, if you know, they are not meant for mass marketing. It is basically a personalized medicine. And Ayurvedic products are not only chemicals. It is a living style, lifestyle. Ayurveda is a lifestyle. It's not a chemical which is available Ayurvedic drugs. There is nothing but as Ayurvedic drugs. So if you know that properly, Ayurvedic product can do wonders. But in these conditions. So that needs Ayush license. A lot of people get it, and we also got the product which I am going to give you as an example after some slide. I will give you in the Ayurvedic product. Then natural herbal cosmetic. This is a part of cosmetic, totally different guideline. Cosmetic drug and cosmetic is there. Cosmetic guidelines are also available. So there is no specific guideline available for herbal cosmetic, but because natural products are gaining importance, this category is also now more in the market, and it is people are using it quite a lot. And phytopharmaceuticals is another category which already I explained to you. It is like a drug, same vigor, same testing as out of synthetic drug. Next. So what you should do? What are the activities generally people do to get these things? These are some any category, but with some respect plus minus. But I'm just giving you requirement for botanical drug guideline, but some diluted form is available, needed for this kind of research is required. These activities are required. Raw material source. This is something very, very different in synthetic and natural. So for example, when you do chemical synthesis, it is very perfect. Means you know what structure it is, NMR, IR, lot of advanced techniques are available. So you are very sure that what it is. What is a assay, what is a purity, what is impurity, that also we know. Natural product, that is slightly difficult. So how will you know that this product is really, suppose I am telling that it is from fenugreek seed or fenugreek seed extract I am giving you. How I will confirm that it is fenugreek only? You will surprise that many of the research papers, we generally feel that research papers are authentic. It's not the case. Authentication should be done, particularly in academic institution, where people start doing master's thesis. The first thing and very important thing is authentication. What you are telling, somebody is giving you fenugreek seeds, whether they are really fenugreek seeds or some phenyl seeds or some other seeds. They look same, sometimes very different, similar things are there, but they are actually different. You will not get the phytochemicals of fenugreek in those things. So naturally you will not get the actions. So first thing is authentication. Now botanical authentication, everybody might have knowing, the pharmacognosy subject is there, which everybody knows that it is done by botanical taxonomical authentication, genus, species, etc. But the second part, DNA barcoding, is now becoming very important. Why? Because there are many companies which they adulterate the natural product with very, very similar compounds. In HPLC you will get the same thing. HPTLC also you will get same. But actually they are from something else. Means active ingredient may be same, but the impurities are different. And if the impurity is poisonous, you cannot correlate the original product with adulterated product. And action will be less also. Sometimes some racemic part is there, sometimes isomers are there. Lot of, if you know the chemistry, there are a lot of possibilities. So natural product, now they made it mandatory that each raw material should be done by DNA barcoding. If you want to export to US at least, this is compulsory. It is not accepted yet by many other places, but if the scientist is there, he will definitely ask for this, whether it is authentic. Then on-site vendor validation. So US is not only require you to GMP to be followed by you, but your supplier. For example, we are making, our raw material is fenugreek seed, we are making standardized extract from that. So that is our area. But they want the person who is supplying you fenugreek seed should also follow GMP. That is our responsibility. This much things are going on. The people, even though you are not directly dealing with FDA, in a business, the particular person, business person will also ask you for this. Then quality control, these are quality control tests are there. Every company should have labs and all. Good agriculture practices is nowadays it is becoming important. Some companies are doing that. They will contract the things and they will make sure that whatever phytochemicals, for example, I want fenugreek seed rich in 4-hydroxyisoleucine. So I will make everything around that. Soil, water, irrigation, place, weather condition, everything will guide the farmer for that and will make sure that 4-hydroxyisoleucine is higher, because if you increase the yield by 1%, you can make thousands of dollars, or maybe it will translate into that. You won't imagine that much change can happen. So that type of research should be done by pharmacognosy people. that just increase the yield, nothing special, no new fancy this extract, that extract, they do all this. Just try to do yield increase, even if 1% will be very commercially viable. So this is practical issue. Then in process testing, not only for final quality control, but in process also. Like suppose critical control point, HACCP is a critical control point. So for our product, for example, pH is very important. We know that pH decrease from 7.5 to 5.5, the constituent of X will decrease by, say, this kind of things we have to do, and then make sure that pH 5.5 is maintained. This is okay for yield and other thing is okay, but if it reflects into some toxic compound, you can imagine the problem. So that's why this has to be clear. The process has to be clear, standard operating procedure has to be followed. So these are the documentation part, and that has to be learned by the student. And if you learn those things, I'll tell you these are the things, these are the keywords. You learn those things, nobody can stop you from getting job. Heavy metal and pesticide, very important. Our Ayurvedic products are having problem because they don't check for that, and we need to remove it all over world if you want to export our products, which we know that activity is there. But because of this quality control, they are not going out. We are not going sufficient cost for our efforts. So that has to be done. Solvent, now one more point. We don't use any other solvent other than ethyl alcohol. We don't use methanol also, and water of course. So we made our procedures accordingly. We can do it with other solvent, but we will not use, we don't want to use. There are many implications of that, and even your customer will need it. Your factory should not use any organic solvent. So scientifically, you can use petroleum ether extract, benzene extract. Practically, if you want to develop this kind of drug, zero use. So right from beginning, you should not use any other solvent. There are many other chemistry related techniques. That's why chemistry is important for this part. So if you know that, you can easily get balance. This is very important. See, ultimately, what is our objective? Our objective is to give the customer a safe product, a good quality product, and efficacious product. And one more point is important, at an affordable cost. So if you want to do that, all four, you need to take care of every part. You cannot, every part is important. And that need people, that need good people who are with understanding of this. Not only, say, quality control person should know about raw material also. He cannot say, cognosy ka part hai. You know, he should know what soil is there, what conditions, lot of things are there. Like these are the things, that is what I wanted to give you message. Don't go for, these are the so many things. You can go to anything. You can do any work. Only thing is you should know that, what you are going to do. Then manufacturing in GMP. GMP is same for all. So like synthetics, that GMP procedures are there. IC, GCP, like GMP. The same regulations are there. Now next part is finished product, which is active ingredient. So finished product in our case is a powder. It's not a capsule tablet I am talking. Formulation will come after that. But finished product for us is an extract, a powder. So final product has to be gone through a lot of rigorous procedures. The particularly important is heavy metal, pesticide, solvents, residual solvent, and microbial. Most important, I will say microbial. Because natural products are good medium to grow for bacteria. If you don't keep it in properly, they will grow and they will have problem with the people health. So efficacy will be out, but this problem will be there. So they are absolutely not, once you get that, it is so important that once you get that, you can lose your business forever, for one batch itself. So that is so important, bacteria. And there are some list of bacteria we have to do, and every batch we have to do, that is important. Then now, mechanism-based quality control procedures are also coming. These are some advanced things yet to come. At present, quality control procedures are instrumental, HPLC, colorimetry, gas chromatography, all these techniques, which you are already learning in your BPharm courses also. So make sure that you learn those principles very well, because machines may be different, but principle will remain same. California Proposition 65 standard. So what my point is, for every of this heavy metal pesticide, this California proposition is for heavy metal. They give very ppm level. So in India, 100 ppm is a standard, which is acceptable. In California proposition, 10 ppm is a standard. So generally we follow strongest or highest possible or we can say tightest limits. If you go for tightest limit, our products are much more easily possible to sell it in India. So we don't have any problem. So California proposition for heavy metal is the tightest in heavy metal. So this is one example. For pesticide it is different. Everywhere you will find these limits. So limits on those are very important and quality control procedures are accordingly. Purity, naturally assay. Assay is the most important. People want to know, and particularly HPLC, like initially spectrophotometric assays were acceptable. Now people are going for HPLC or HPTLC. These are the two standard equipments. And last part is stability. On powder I am talking. These are the same. ICGCP has already listed stability guidelines. Same thing you have to follow. The same procedure, not for formulation. Here we have to talk about powders. And you have to mimic the packing. Say if you are putting HDP drums, you should have small HDP drum and put the product. You have some plastic pouches, you have to do that. So all this. Next. These are, now first part was chemistry part, now comes to biology part. Now this is slightly known, so I will just go slightly faster. So basically in vitro, in vivo test, the same thing what we are doing with synthetic, same thing we have to do here. No change, absolutely no change. So here in vitro, in vivo studies, animal models, you have to get the potential mechanisms with in vitro or ex vivo or in vivo, same thing. Pharmacology. Then you have to come to safety. Here there are guidelines, again same guideline as synthetic, which is called as OECD guideline. So that is also listed in their website. There is a huge list and you can see that. Generally these are sufficient, acute oral toxicity. Now depending on the route you have to talk. So we generally go for oral. So oral toxicity, 28-day, 90-day, 180-day toxicity study in rat and mice, 2 species. But here rat, mice is okay. Here advantage is in synthetic you need to go for one small species and one large species like dog. Before you apply for IND. In natural you don't need to do it, one species is sufficient. So that is slightly good part of it. Chromosomal aberration, which is for carcinogenicity, mutagenicity, all this property. Toxicity evaluation has to be done properly. The next part is clinical trial. Again same guideline, good clinical practice. Everybody of you might be knowing about it. These guidelines are there. Very stringent guideline. Double blind, placebo control study. You know the design. If you don't know, see, I am just not getting into details of that. Each of these, say for example, this third row itself is a one lecture. So I am just giving you some keywords. You get that keyword, search it, you will get a lot of information. With internet, there is nothing dearth of that. So these are the clinical practice guidelines are available as per good clinical practice. You have to follow all the norms, ethics committees, or patients related. Documentation is very important part here. And if somebody is interested in information technology or computers, data management is a very big area, plus statistic. If somebody is interested in statistic of clinical trial itself is a big area. You can make whole career on that. So you have to learn for the software called a SAS, Statistical Analysis System, or SPSS, and you can need some programming. But you should know the statistic first. So that's slightly more advanced statistic than what everybody knows. And then there are regulatory, those who are interested in documentation. They want to sit and read and they understand and they like that basically. Some people like documentation, some people don't like. There is a black and white, there is no in between thing. So what you are, whether are you white or are you black, means do you like documentation or you don't like. Depending on that you search, take that. Huge requirement, there are not many people. Let me tell you, this is very, very niche area, and if you know, if you have knowledge of regulatory guidelines of all over the world, and if you enjoy that to make the document, this is a huge demand is there. There are not many people who are having patience to read all these things. Then in the regulatory only, there are certain another area called as legal. So some people are having this kind of career also. B.Pharm with LLB is a great combination. So you can go for this kind of thing. Like as I told you, there are certain categories which are OTC, certain categories which are not. So OTC categories are regulated by this kind of laws. If customer has some problem, he can complain to government and government can open the query. So OTC products are also not very, you have to take responsibility of that also. It's not, so that is why evidence based you should do so that you are safe. So if you are evidence based, you are safe here. Okay. Consumer awareness is also another thing. It is increasing. People are having a lot of questions. Even we are doing into Amazon, so a lot of reviews, lot of questions comes. Now people want to know more about these things, and most of our customer, for some of the customer, as I told you, our sports nutrition product, for that customer will go to gym goers, fitness enthusiasts. And these people, if you know, they wanted to learn about physiology and they wanted to take care of their body and they wanted to develop their body into some direction. So the person who is developing his body for badminton playing will be different, for boxing playing will be different from weightlifters. These are all different players. So they need to do something different with this same thing. So their question will be oriented toward that. Are you getting what I am trying to tell you? Customer requirements are different and people are now becoming aware about it. And that is a good sign. And then last is patent. Patent, if you wanted to sell and suppose there will be copy possibility. So protection from that. Next. These are all certifications. Ultimately, see, when you do this, how customer will know that you are following this GMP? How they will know? Each customer cannot come to your factory. So that's why certifications are there. So each of the certifications are dealing with, they will come, they will have audits. And those audits, based on that, it is like accreditations, basically, of educational institute. These are the quality control certification and accreditation. Some of them you might already knowing, and most of them are quality related. So just it is giving a list, and there are a lot of such things, but I'm just giving you a brief list. If you go to those individual sites, if you are interested in this kind of accreditations, you can do some course after B.Pharm, and again there is these are the unique areas and lot of opportunities are there, particularly if you are pharmacy student. Next. So as an example, just I'm giving you, which we already have, based on whatever we already learned, how we implemented it. Everything cannot be implemented for one product, okay? Depending on product, we have to select it. So now this is one product which we know that cinnamon bark is known for immune system, immunity improvement. So we realize that suppose we use this product for allergic rhinitis, sardi, khasi, jo hota hai na. So we try to do that. Next. So these are traditional users, but we are focusing on immunity. Next slide, you can go. So what we did is we try to identify which of the product which might be having this activity. So we found that total polyphenols, and within that also type A proanthocyanidin polyphenol is there in cinnamon bark extract, and that will be this is a polymer and basically pentamer, and this pentamer, if you keep it in that form, it will give you some good properties. Some of them were reported very crudely for extract, not for extract, for unstandardized extract, I will say. We isolated this, we made a patent also. Now we have to go for the patent, PCT and all these things we did. But another point we realized that in market, they always talk about coumarin free, because in cinnamon extract with polyphenol, coumarins also comes. So your extract should be free from coumarin, and there is a limit, actually very stringent limit, and there most of the manufacturer fails. So we developed those technologies and we made that coumarin free. That was, see, sometimes you have to have something which is your USP, and that will stay in market. So that is what we did. Then we did preclinical, clinical and studies. Next. So here we did safety studies as per OECD guideline. We did, now here there are a lot of things are gone in between these two slides. Actually these two slides, let me tell you, there is about 5 to 6 year gap. Now you'll say why that gap is there? Because we were not sure we are to do nasal spray. That is afterwards. Everything cannot be decided initially. So what we did is we tried to go for botanical drug guideline. We tried to develop a drug for HIV. In fact, we did application for IND in US. And they got it. Means they said, okay, no problem. This is good. You should do it. This is 2007. This was the first IND application from India, first, on Indian address. There are a lot of people, but all of them are, Pfizer, Glaxo, many people. So that time we got very good opportunity, but we couldn't get funding for that because huge, and acceptability and everything was, that time natural product acceptability in 2007-8 was less. So we have to go through. So we thought on that, how to do, what to do, lot of things we did. So I'll just not going through details of that history, but ultimately what we did is, we did toxicology. Initially we did toxicology on oral. Acute oral, 90-day repeated, mutagenicity, that is a raw material. Then we made a spray, and then with the spray also we did the safety. Nasal spray. So here again OECD guideline, but dose was different. 100 microgram per rat per day, which we tried. Because initially actually efficacy study was done first. Based on that we decided to do those. Actually that I will show you afterwards. So this study, then after that we did 28-day repeated dose toxicity and then in vitro safety study. These are safety study basically as per OECD guideline, which we publish. You can go through the paper. These are standard guideline, everything is known, so you have to just follow it, nothing special with this. Only special thing here is, there is no guideline in OECD for nasal spray. You just see that, there is no guideline. So we have inhalation guideline, but inhalation is different from liquid. So we decided, we thought, we took some suggestion and we did it, and it was quite successful because FDA also afterwards approved it. Not FDA, but similar to bodies. Next. This is a preclinical efficacy which we did actually before safety. Here what we did is oral albumin induced allergic rhinitis model in bulb C mice, which we did. By the way, this you can see some known names which is done in Seagan Institute of Pharmacy. What I am trying to tell you is, these studies, even though products are in market, they are done in academic institution. The people who are MPharm student, that time Amit Kandare was MPharm student. Now afterwards he did PhD also. But thing is, this is a collaboration work. This is an industry academic interaction. If industry knows what they wanted to do, and if institute knows how to do these studies with good quality, in fact we did lot of good documentation. Your student also, they help, it helped the student also. Amit Kandare is having very good career today. So it is this the study is about 10 years back, which we published, and in fact afterwards we got prize award also for this. In one of the conference, IPS, we got award. So this study we did, basically what we try to do is, these parameters are known. There are plenty of the papers are documented. This model is not new, this is an old model. Parameters are also simple. ELISA methods and this. In fact, we did video tracking, and we actually recorded sneezing from animals. We have this recording. So that type of documentation you need. So how sneezing in bulb C mice looks, we have that videos. So this kind of thing we have to do, and proper documentation. Of course, everything is not reported, but it's not required. It is just a research paper. So this paper we published. Next. It's a phytotherapy research paper. It's quite good. Then we came to, because safety is done, efficacy is done, now clinical trial. Naturally, we did 2 clinical trial here. On seasonal allergic rhinitis student, not student, subjects, I will say, not patient. Patient also you can say they are generally treated as disease. And we did this in Mumbai with one chest specialist actually. So we took a clinical trial, we had to do everything exactly same as synthetic, no dilution there. So 100 microgram in nostril twice a day for 4 weeks, and this quality of life is a primary endpoint, which is primary endpoint for all previous clinical trials. Take it Glaxo, Pfizer, all nasal sprays. which are there in the market, they utilize this RQLQ, Rhinoconjunctivitis Qualitative Questionnaire. This is given by Juniper. Now one more point I wanted to focus here. This RQLQ is a quality of life questionnaire which is developed by Dr. Juniper of UK. Now we wanted to have a Hindi version of that because it was easy for the patient. It's a patient reported outcome. Now in clinical trial you need to have, if you want to do proper clinical trial, validated questionnaire. Remember this. It's not questionnaire which you will take, a lot of people do in their BPharm also some projects. I will ask A, is it this, is it that, 4 choices and you got the survey. No point. Don't do this kind of nonsense work. It will not be appreciated. In fact, it will be negative impact. So remember one thing, every questionnaire you want to use in your research has to be validated questionnaire. In the same language, point is translated and validated. So that translation and validated questionnaire cost us 1.5 lakh rupees that time. Remember one thing, we are paying, the Indian company is paying for that Hindi version to UK scientists. This is not good thing for us. We are there, we should do this work. And we did in fact with one of the research student, Srikant Pawar, who did diabetes questionnaire, translated, validated, and this was his PhD topic. And then he got job also on that because there are not many people are there. So point is, we have to do research which is useful to the our community, our nation, our people. In our case, Hindi, Marathi, we have to do that type of thing, vernacular language. So if you can do that, you can be complete researcher. Otherwise, I would not have felt I am complete researcher, even though I would have done lot of papers. So your paper should not be put into the shelf. It should go to the people and useful. Next. So second study, what happened in first study is, first visit was on 14th day after starting. So after 14th day people were not ready to come. बोला क्या हुआ? हो गया ना, अभी क्या करना है? 2 दिन में ही तो हो गया तुम्हारा मेडिसिन, काम ही कर दिया. We thought that natural product will take time to heal. So let us keep 1 month. This is another point I wanted to tell you. Natural product also can work as fast as synthetic product. You might have heard this first time, but we have these experiences. So they said 3 दिन में हो जाता है, and most of the people told that. So that's why we did second trial, where we did 24-hour ready, 3 day, 5 day, 7 day. And this study was done in the place where is a highly populated AR patient population, which is Australia. If you know the geography, see, there are a lot of things you have to think. Why only Australia? We thought that we will market in Australia. Why? Because you will know that all other places in the world, you know how many patients are there, allergic, I am talking about allergic rhinitis patient. I am not considering normal sardi. In India, 15 to 20% patients are allergic rhinitis. Very serious disease, actually serious condition. That nose will become red, face will become red, eye will be completely wet. And they are this same, particularly in March, the pollen grains will cause this allergy. It's a very dangerous thing for them. In Australia, whole Australia is like that. And particularly allergic rhinitis is very much more prevalent in coastal areas. And Australia, complete population is coastal only. If you see the Australia where people live, they are in coast. So about 30 to 35% Australia, and some persons told me that it is 50%, is allergic rhinitis. So 1 in 3 people, there are allergic rhinitis. I am not talking about sardi, khasi, jo bolte hum log. No, that is common cold. It will work in that also, but this is more serious condition. So this is called as hay fever there. So those patients we do similar thing, and we got result in 24 hours, and 1 dose, 2 dose maximum. So we are using in our case. Of course, both these trials are done in adult. We have to do one trial in children actually, which is very big population, which is maybe we'll do it sometime. So these 2 trials are sufficient to put this in market. Next. Then this another point is, it is working, you can see, but how? So for that answer, we need to do some in vitro testing. Again, this we did, mast cell degranulation, because there are reports and we thought that this is a possibility. So we did actually 4 experiments we did on that, and ex vivo, in vivo plus ex vivo, some schedule. There are some methods to do it. So that we published with Amit did that study. That is also another study which he did in academic institution. Then anti-inflammatory studies, in vitro study again. This is done, but not in Indian academic institution, it is in Taiwan. But this is typical biotechnology institute, which they do cell tissue culture, that type of thing. So they are expert in that, so we did it there. It was published. So we found that it has an leukocyte attachment blocking, and you know that leukocyte, that diapsis is a major reason to cause inflammation, and that inflammation is basically contributed by allergic rhinitis. So allergic rhinitis has 2 parts. One is allergy, you have to stop, and inflammation also you have to stop. So, and the third one, which we actually did lot of work on that, allergic rhinitis patients are more prone for these viral infections. So that time HIV was very in a serious threat. After that we did COVID also. In COVID season we did clinical on that, but it was not found, as compared to placebo, it was not found useful for COVID. But HIV, HCV, we got very good result. Next. But HIV, HCV we did oral, not in nasal form. Next. So these are details, Ig in mediated sensitization inhibition and mast cell degranulation inhibition. So there are papers which we published, and you can see the mechanism. These are typical, mechanism studies which generally people do, in vitro studies, with a very popular clean hygienic lab which has some good approvals. Next. This is pan-selectin antagonist. This selectin is also another mediator of chronic inflammation. So where we did this. This is in another way we can explain the. So these are the 2 basic mechanisms which we are proposing. Next. Now next part. This is more difficult part than all this previous thing. You know what happened? We did that. We are happy. Now we will do it in market. When we did, after 2 days, there used to be a turbidity, and it was these particles are accumulating, clumping. I will say clumping of this ingredient, which are very bad also, and it is not acceptable also. If 2-3 days, then I need to go for formulation. So we just talk with many people, and but before that I need to do some study. I am not a formulation scientist. But I tried to get some 12 different reasons why this must be happening. But the most common reason was very simple. And you also will know this. It's a very general knowledge. Everybody of us experienced this. You know where? Apple. And you will surprise what we are talking, type A procyanidin polyphenols, you will get in apple also. And then I realized that what they must be doing when they do clean apple juices. Apple juice don't get. So what is happening is, it is a polymer, as I told you. It was polymerization reaction is happening with oxygen and with particular temperature. So either you have to reduce the temperature or you have to avoid the oxygen. That is what we did and that is, so my point is this concept, we have to see where it will. So I got this idea from wine papers, research paper related to wines, not with pharma. Because natural product nasal spray is different than synthetic nasal spray. So if you go for formulation literature of nasal spray, you will not get all this. You need to go something different. So we did it and we found, then we did stability. Now it is 2 years stable also. So this is what we did. After that, lot of formulation combination. In fact, the final formulation is done by again in one academic institution. And all these academic institutions are in Pune and around. This was done in D.Y. Patil. After that, that lab did some more nasal sprays also for us. So Sanjeevani Deshkar madam did this study. So we do this industry academic interaction sometime whenever these are the places. Next. So ultimately now this product is in market. This is Amazon packing and this is some other place. These are the claims. Now I want you to see the claims properly. These are the claims which we have to do exactly like this, because these are exactly these wordings are mentioned in the listed medicine approval in Australia. They have exact wording. So we took from that, and in India also we use the same wording because we found that it is quite good. So wording, when you go for this wording part, very, very important. If you make it wrong, that whole product can die because of one word. It happened. And that is what, after this good science, you should do good commerce also. So this is a part of good commerce. Next. So this is what now at present the status is. You can go to Amazon. I hope you will not require this. In some other product, I will say that you take it, but not this. But if somebody needs, you can say that. Thank you very much. So any questions if you have, please ask. Even if you feel that it is very basic, you ask. Because there are so many keywords, you need to take maybe some time to digest, but let them ask questions.
Sir, cinnamon is a very widely used spice, then why we need to go for oral toxicity?
Very important question. Now, how much cinnamon we use? Generally in pulao, just now we got some pulao. How much you might have consumed? Just imagine, how many grams? Approximate. Very small amount. That is not sufficient for medicinal effect. You need to have that. That is the first thing. Second thing is, if you tell people to take cinnamon, knows they cannot take, first of all. So formulation is the first part. But before that also, as I told you, coumarins. Why you cannot take that much cinnamon is because of coumarin. So that dose is very important. How will you know? And before that, we processed it. Remember, this is not cinnamon powder. This is cinnamon bark extract, hydroalcoholic extract of cinnamon bark, standardized to 40% polyphenol, which is very, very specific thing. It is not very general thing. So the moment you change that thing, instead of hydroalcoholic, you take some other extract, this toxicity will not work. Now, how will you know that this safe? So first is safety. So here you know that this much is very safe. Up to 100, even 1 month, even if I take, it is safe. So that is first thing. So unless you standardize, you cannot use that. And so that is a major reason. And here what we are using cinnamon for, not for medicinal purposes. It is for very different purpose we are using. It is for just fragrance, not flavor, you can say, not for medicine. When Ayurvedic practitioners use cinnamon, they powder it and they process it in some manner, sometime in honey. There are a lot of formulations, very, very specific to Ayurvedic formulation. See, Ayurvedic product also should be taken in that formulation. If it is Asav, it should be Asav only. There is a process for that. Many good Ayurvedic companies follow that. So in this case now, we should be very particular about this process part, which is told in Ayurveda books. In Taiwan, I visited one factory of traditional Chinese medicine. So I saw around 10 different chambers. So they are taking one from one chamber, they are putting into other. So I just saw that chamber is looking same. There is no special instrument inside. They are not doing any process also. So why they are changing that chambers? I asked them, why these 10 chambers are there? Is it some space issue? No, it's not space issue. In traditional Chinese medicine, they told that you have to keep this particular powder 24 hours in this particular condition, so temperature and humidity. Then for next 48 hours, you have to change the temperature and humidity. For next 72 hours, this is process they are given. And they are exactly following the same thing. This is what we should do in Ayurvedic product. Whatever they said in that book, just don't tell that, okay, cinnamon is having immunity boosting. it will not happen. Effect will not be seen. We have to process it as per that book, because they already thought on that. It's not just something they wrote. They might have already have thousands of years experience that if you go with milk, this will give better pharmacokinetic. They might not have called this as a pharmacokinetic, but concept is same. Or this particular Prakruti, that is a personalized medicine. So this Prakruti and this medicine will work together. So a lot of things has to be seen again, and we have to follow that. So we are not doing all this. So that's why we have to do everything like the way. So either you have to follow that or this.
Thank you, sir. It was a really great session. I have a question for you. Can you throw a limelight on the thing that is BPharm plus LLB is a good career option?
Yeah.
Apart from that, you have said that some certifications provided by company that claim that we are providing the best particular product. That certifications are like ISO, NSF. How one can proceed a career in that particular?
Okay. This is actually easier option than doing MPharm. But people should take it as a passion. See, point is, courses are there. See, I myself did, when I was in job, I did 6 to 7 courses of IPR, intellectual property, patent. That's why I was interested there. So it's very simple. I realized that there are a lot of courses, but they will give only certificate. Don't go for certificate. Nowadays, YouTube is also sufficient, actually. A lot of good things are there, but if you need some paper, that also available. There are a lot of organizations which are expert in this. For example, World Intellectual Property Organization, WIPO, is doing all these courses. Now also they are there. It's a very, very insignificant fee is there. Hardly at that time it was 6,000 rupees for a course of IPR management. And if you really see the material, you will stun with that. It is so good. Perhaps it is the best material I have ever seen. So, and that course is case oriented. It is not theory. It is a quizzes. So as an exam, they will give you case, and you have to. It's not that 1 hour exam. It is some 2-3 hour exam, and you have to write, and online you have to upload it. The case they will give you within 3 hours. You can refer any book, or you can refer even AI and all, whatever AI you can use AI. I haven't talked about AI. Basically, it is very big area. A lot of progress has been made in naturopathic also, but that is also different. So that is one thing, and this is for IPR. Now about this regulatory affairs, there are some good organizations like there is one very good course. There are organizations like on International Regulatory Affairs Organization or international I'll send you, madam, some names if you are interested. So that organization gives proper exams. They don't give courses. If you want, they can give courses also. But my point is focus on accreditations, exams like GRE. You know GRE. Everybody knows GRE. GRE organization will not tell you that you do this course. Wherever you do course, you can do X, B, Y, Z, YouTube, anything. This is my exam, you appear it, simple. That is how you have to proceed. This is another possibility. Third possibility is for law. Best way is to do LLB. Proper 5 years LLB, which you can do part-time also. You will say that 5 years after BPharm 4 years. But if you want to do something, you have to sacrifice your... But I'll tell you example, 2 examples I'll tell you. This is what is done by one of my junior. He was he was a formulation scientist. He was doing PhD, and at that time he did LLB. Okay, PhD, full-time PhD, you have time. I think you have time. Weekend courses, weekend practicals, easily. But he knows that he wanted to do. And you won't imagine what is his career. He was ahead of lakhs of people. Just his PhD in pharmaceutics. He got job very easily in, at that time, Dr. Reddy's, then Ranbaxy. Then he got posted in Switzerland. Many years he was in Switzerland. because there are some business things, Lupin, send him. So there are many good opportunities he got just because this combination. Lot of good opportunities. BPharm LLB is a huge advantage, you cannot imagine. Even one more I haven't told you, you know health insurances. So health insurance companies are always trying for pharmacy graduate. They are always in shortage. They don't get it actually. So what they are doing, just imagine, you just see and you will get the idea. My point is, don't think in one direction, there are a lot of possibilities. Medical writing is there. Write about this thing, clinical trial report and all. Those who want writing. Then even lot of websites are there, health related website. So that type of things are also there. Lot of opportunities are there. My point is, don't, initially 20 years back, because of internet was not there, limited things were there. Production, quality control, R&D, maximum teaching. These are the only thing. Now all these opportunities are there. And with internet, you have really a lot of advantage. Lot. So I think I answered your question.
Hello, sir. Sir, there are many herbal supplements. There are many herbal supplements and herbal product which containing active ingredients, which is also obtained from natural sources. So phytopharmaceuticals is one of them. So why phytopharmaceuticals required to take permission from GIA?
Yeah. First thing is, suppose we have standardized extract. We can say say 4-hydroxyisoleucine is a marker. So we have this kind of thing. Or you can have group of molecules, like standardized to alkaloid. Total phenolic content is an example. Now if I want to go for phytopharmaceutical, they want 4 active ingredient isolated and shown as a HPLC fingerprint, pure compound, like trimer, tetramer, which you could have isolated and characterized separately as 100%. So it is more stronger way to tell, and in return you will get marketing authorization. Means if somebody is again giving cinnamon bark extract standardized to similar polyphenols, if I have this 4 compound, say I have compound A, B, C, D, 4 peaks, I identified 100%, showed that and did all these detailed studies. Even with that pharmacokinetic and all these things is also needed, which is not required in the previous one. But they will give you authorization means 6 years. They will not give license to any other cinnamon bark extract. Naturally, and then second advantage is insurance companies can reimburse that. Means if doctor is using that, he is insured about, because he is now FDA approved by. Huge advantage. So then you can charge double. Simple. You have to do something, you have to get return of that. So but by the way, phytopharmaceutical is not at present, not a single molecule is got, according to my information, in phytopharmaceuticals are not yet, nothing is approved. Actually now it is coming that NDA level 1 or 2 drugs are coming. So difficult, but they may have a long term some advantage, we don't know. So phytopharmaceutical is that. It is similar to botanical drug guideline. So in last 20 years, only 2 botanical drugs are approved. You can imagine how difficult it is. So there is a provision, practically how much you have to spend time. So people may think of practical issues. Some people did, so they are doing it. Difficult. But there are certain advantage, scientific advantage, commercial advantage. Student side, anybody, please. So take first step for your career. Ask the question. See, as a student, you can ask anything. That is the advantage, na? So have you got what I told you, or it is just bounces? You got something, right? May not be 100%, but at least something. Sure? I will ask her what you understood.
Thank you, sir, for the valuable knowledge that highlighted the importance of GMP, standardization, authentication, impurity testing in formulation and evaluation of herbal drugs. Your emphasis on clinical research of herbal formulations followed by regulatory requirements is indeed a great field to explore. Your expertise has deepened our understanding of the exciting possibility in herbal drug development. Now, I request respected Registrar Dr. Deshmukh ma'am to felicitate Dr. Thakur Desai sir as a token of our appreciation and gratitude. Thank you, ma'am. Thank you, sir. Now we are about to dive into our next technical session. The topic is the developing chick embryo as a model system for biomedical research. The chick embryo has become an invaluable tool in scientific exploration, offering a unique window into the mysteries of early development. With its large size and transparent nature, the chick provides a hands-on approach to studying embryogenesis, organ formation, and tissue differentiation. Let's explore how this tiny yet mighty organism is helping in shaping the future of medicine and healthcare. I request the dignitaries to take the seat on the dais. Please, ma'am. Now, I hereby request Principal LTIPS, Dr. Meenakshi Devdar ma'am, to welcome Dr. Datar ma'am with a bouquet. Please, ma'am. Thank you so much, ma'am. It is my privilege to introduce Dr. Savita Datar ma'am, a distinguished educator, researcher, and a social contributor. She is an ex-principal SP College. Respected madam holds a PhD in zoology from Pune University. She has developed groundbreaking models for biomedical research, including shellless chick embryo culture model for angiogenesis studies. Ma'am is a recognized postgraduate teacher, guide for MPhil and PhD students at Savitribai Phule, Pune University. Beyond academics, she is a committed social worker. She currently serves as a treasurer and branch executive committee member for the Pune branch of the Family Planning Association, an international NGO. Ma'am is a life member of esteemed scientific societies, including Society for Neurochemistry, International Society for Stem Cell Research. She has been honored with several prestigious awards, including National Merit Scholarship, Shikshak Gaurav Puraskar, and the National Award for Contribution to Teaching for her outstanding contributions to education. Her dedication to education, research, social service is truly commendable. With this, I kindly request Datar ma'am to proceed with the session. Please, ma'am.
Good afternoon, everybody. And thank you so much for inviting me to share my work. Actually, this is the last session of your conference, and you have been listening to all such academic sessions since yesterday, and today since morning I have seen your schedule that there were lectures on personalized medicine, nanotechnology, as well as just now the lecture which I heard. And now this is the last lecture in your series. Again, a post-lunch session. So I think I have structured my lecture because of that. When I came to know that this will be a last lecture in the series and post-lunch session, so that I structured my lecture or a speech in a particular way that it will contain lots of photographs, some videos, and something like that. So the title of my talk is Developing Chick Embryo as a Model System for Biomedical Research. Next slide, please. So that we know the term model. Models are there in fitness industry, in fashion industry, and everywhere. So there are models in biology also. So use of models in biology is very crucial for understanding many phenomena which occur in the body of multicellular animals and actually in human beings. But every time human beings cannot be used to check the things which have been, like just now sir told that herbal drugs development. So the drug which is developed cannot be immediately checked on human beings. You need a system which will function in a similar way, closer and closer way as that of the human systems. That is called as a model. So there are, you might have heard E. coli is used as a model, mice, rat are used as models. Drosophila has played a wonderful model for genetics. Similarly, I will be talking on how developing chick embryo can be used as a model system for different aspects of biomedical studies. Actually, I have restricted my talk to only 2 model systems making use of chick embryo. If you can think, and you will think and you will find out, every part of chick can be used as a model system for many different things. And I also have used chick islets for diabetic studies as a model system for diabetic studies. These are chick trachea as a model system for respiratory agents studies, and so many things. Even chick embryo fibroblasts, they express many stem cell markers, and we can use them as stem cell source for studying differentiations and other aspects of, that is a model system which will function similar, because getting stem cells from mesenchymal stem cells or embryonic stem cells or pluripotent is a very difficult thing. So first, to learn and check the things, you need a model. Then you can go further for a mammalian model. Then you can go actually for larger size models, and then actually to the human beings. So nowadays we know that cell cultures are used as model systems. After doing a thing on cell toxicity for cell cultures, for example, once you study, then you go for some larger models. So similarly, chick is used as a wonderful model system for different aspects of biomedical studies. Before going further, I just want to talk on this, that all of us know that it requires 21 days for a chick to hatch out of the egg. And inside the egg there is a large yellow ball which is a yolk that is called the extremely telolacethal egg. Because of this large heavy yolk, the nucleus in that is a ovum, right? So its nucleus lies in the thin peripheral film of cytoplasm. So that whenever fertilization takes place, the embryo is growing in a very thin peripheral film of cytoplasm in a chick egg. And because the yolk is very heavy and the embryo lies at the top of the yolk, any way you hold the egg, whether horizontally, the embryo will be immediately just below the top. If you hold the egg with blunt end upwards, the embryo will lie just below that, or tapering end upward, even then the embryo will turn, that is the yolk will turn and the embryo will be at the top of the yolk, right? So this is the accessibility of the embryo, and it can be seen through the vitelline membrane. Next slide please.
So because the embryo lies just below the shell, anyhow you hold the egg, it is easily accessible. It can be seen through a transparent vitelline membrane. The eggs are very cost effective as well as easy to handle. Growth is rapid, within 21 days the entire development takes place. And the most important thing is, during evolution, birds evolved with a divergent evolution from a common ancestral reptile. Birds and mammals evolved with a divergent evolution from an ancestral reptile. So birds share many physiological characteristics with mammals. So bird or avian model becomes a more valid model to study many things which you want to study with mammals. So if you study it in chick embryo or avian embryo, then you can go to mice and rat and then dogs. Afterwards you can go to actual human beings. So it becomes actually a very good model because phylogenetically it is closer to human beings. Birds and mammals are the only animals in the animal kingdom which are homeothermic. The life cycle is short, so the results can be achieved very well. So because of all these things, next slide please. As well as during these 21 days, the development of the chick which takes place has been thoroughly studied, and depending upon the morphological characters, embryos have been differentiated into series of 38 stages, right? And this allows making an experimental setup as per the aims and objectives of the experiment, so that you can bring freshly fertilized eggs from the poultry, incubate them to see a 24 hours embryo or 33 hours embryo, and see what structures are developing. Because this information, this database is available. This has been published in 1951 by Hamburger Hamilton, and the stages are developed, stages are differentiated depending upon the development of morphological characters, not hours of development, depending upon the morphological characters. So that, and all these are, there are 38 stages, and this is available as a very strong database to us as a Hamburger Hamilton staging system. In addition to this, there is one more database which is available, is a Carnegie stages. Carnegie is an institute in Washington where stages of development of all animals have been studied, and a graph is plotted where you can see that chick embryo stages can be correlated with stages of development of any other placental mammal, including human beings. Right? So that within 21 days, if you want to study a third day incubated chick embryo, what happens to the effect of certain agent on it, you can extrapolate these results probability to what is its effect on the human embryo. So approximately it is found out that 7 days in chick embryo development are equivalent to 3 months of human pregnancy. 3 months of human pregnancy. So that is how the studies which are done using chick embryo as a model can be extrapolated very well for the humans because of other things also, because they share physiological characteristics. Right? So because of all these two things, and again it is mentioned and it is noted that development beyond stage 21, that is 96 hours. Development of chick embryo beyond 96 hours is characterized by the growth and maturation of organs only. Means all organogenesis is complete up to 96 hours. What happens afterwards is only growth and development. So development is very fast. 7 days of chick development are equivalent to 3 months of human pregnancy. So with all these characteristics of developing chick embryo, next slide please. Different systems for its culture are in use and were developed since very long days, like 1955. Because it is accessible, because it is easy, because it is comparable with the human beings, and Hamburger Hamilton staging system is there, Carnegie system, graph shows correlation. So scientists were naturally very much inspired to develop chick embryo out and to see effects of many things. So many of different systems were developed with different aims and objectives of the experiment as per the scientist who wants to do that. So simple system was like window system. A window is made in the egg shell and the embryo can be seen through it. You can treat it with the agent, close the window, again incubate in the incubator for 24 hours, 48 hours, whatever your setup of the experiment. These are called as window techniques. Another is called as ex ovo or shellless cultures. Like take the entire contents of the egg outside the egg. And there are different array of the shellless culture systems were developed, which is a see-through system, like in the glass containers. Every scientist has used some different type of container because his aim and objective was different as per their reading. But there are series of such shellless culture systems available. You can go through these different culture systems and for what they were used, what was the benefit, what was the outcome of these systems. And third is ex ovo in vitro. Like you can see that the embryo is taken out from the yolk along with the vitalized membrane, and this is supported by different ways, on a paper ring, on the telescopic glass ring like embroidery ring, and the nutrient is provided to it. But all these systems have their own advantages, limitations. They are very wonderful systems, culture systems in the field of biology. These are still used by zoologists for many experiments. By making use of all these different culture systems, developing chick embryo has been used as a major model system in developmental biology. You can really see how heart develops, how brain develops, how torsion occurs, What is the method of limb development? How first only the club-shaped limb develops and then the fingers develop. So all these things can be studied with these models, right? So the chick embryo model has been used for this developmental biology, immunology, toxicology, cancer research. Still it is used. However, cultured chick embryo had never been explored for diabetes research till 2003. Next slide, please. Right? And glucose-induced developmental malformations like pregnancy diabetes is very common. So what happens to the developing fetus if mother gets diabetic? These developmental malformations in mammals like mortality, spontaneous abortions, retarded growth, embryonic dysmorphogenesis, like macrosomia, large size babies are always born to diabetic mothers. Macrocephaly, only head is large, other body organs are normal. Or central nervous system malformations, malformations of cardiovascular system, rotational. These were studied using in vivo mammalian models. So mice were made pregnant, they then were made diabetic with STZ, and the invasive investigations were required to see what happens to the developing embryo if mother gets hyperglycemia. So what we aimed is to study the potential of developing chick embryo for glucose-induced malformations in human embryos, that is gestational pregnancy. Next slide, please. So knowing that organogenesis in chick is complete by Hamburger-Hamilton stage 21, that is 96 hours, and the available chick embryo culture techniques could support development of chick embryos up to certain stages. Right? As per the requirement of those scientists, their aims and their objectives, we decided to develop a culture system which will support all the early stages of chick embryo development. Right? But because up to 96 hours all organogenesis is complete, I wanted to see what happens during organogenesis if mother gets diabetic. And the systems which were available in the literature, which we saw idea of such, they were having skipping some of the other stage. So I cannot use one system for one stage, another for the other. So we decided that we will develop some culture system. And after a work of about 8 months, while using different types of containers, seeing how much it works, how it grows, and plotting a graph of mortality and all this in about 8 months work, we found out that a simple autoclavable glass bowl of these dimensions and a normal 9 centimeter diameter petri dish becomes a wonderful assembly for shellless culture. Next slide, please. So the scheme of shellless culture of these embryos is the eggs have to be incubated in the incubator at 37.5 degrees centigrade and 70% humidity, and the care should be taken that eggs should be incubated in the horizontal, not upright, because we know that however you hold the egg, the embryo will be just below the top. So you should not rotate it, keep on rotating it once vertical and other times horizontal. So all this was studied, that is why it took 8 months for me. So horizontally eggs should be incubated, and the egg which is taken out should be kept outside the incubator not more than 10 minutes. After that it should be broken with one hit of a scalpel or some heavy thing, only one hit, because many vibrations will increase the mortality of the embryo. And the hit should not be in the center, because just below the center the embryo is there. So towards the narrow end, one hit, and release the contents in the autoclaved bowl. Culture should be closed with a loosely fitting petri dish, not completely fitting, it will suffocate the embryo. And then incubate the cultures in the incubator with 37.5 degrees centigrade. Humidity is also very important. And after 24 hours, 48 hours, whatever time span you want to study the effect of a particular agent, you can take out the cultures, put a Whatman paper number 2 ring over the embryo by trapping the embryo in the center, cut the white line membrane from the sides, just lift it and make it upside down in a petri dish containing 0.9% saline. Wash the adhering yolk. You can observe it under the stereobinocular microscope. Only live embryos should be counted and photographed and seen for further studies. Plus you can do biochemistry, you can do histology, you can do protein, you can do DNA, everything. Once you have treated the embryo, taken it out, harvested it, fix it for the histology, use it for biochemical analysis or whatever you want to do. Take photographs for morphological observations, and you can do many things. Right? So this was very simple for me, that I used to bring freshly fertilized egg as early as possible, because freshly fertilized, if you want to see what happens at 24 hours incubation, you should get some time. The eggs should be kept in the incubator, take them out, and then treat them. So this was my scheme of shellless chick embryo culture. Next slide, please. So these are some photographs. You can see day 1, day 3, day 4, how the embryo is growing. You can see the bowl edge. It was growing in the glass bowl. But all precaution what you have to take for the culture, you have to take. You have to do these cultures in the laminar flow. The incubator also should be sterilized. Aseptic techniques should be used because it is very prone to contamination. Yolk is very highly nutritious. So you have to take all these precautions. And next slide, please. You can see how the embryo is developing. You can really see different organs, how they are developing without touching the embryo. So if you want to grow it beyond 8 days or beyond 6 days, you can add some amount of albumin at the bottom and then put the embryo up so that it will function like a cushion for that. I was interested only up to 96 hours active stages of active organogenesis. These photographs were captured just like to see how long this system can support growth of embryo. And any other experiments also can be done. I was interested in diabetes research. I was interested in active organogenesis stages, so I did it afterwards only up to 96 hours. But these are the series of photographs to see, and for these I have to add albumin at the bottom. So that albumin can be from unfertilized eggs. Next slide. So you can see all these things, how a chick is developing in a bowl, and really we used to play with these chicks, like whether they can identify some reflex, they give some tapping on the petri dish or something like that, and they used to respond. Next, 18 days, 19 days, you can see. Of course, this is not the chick which has come out of the bowl, because that was not our aim also. And the thing is that they become weak. That can be studied. Another thing to study, that the shell gives calcium to the developing chick. So we can add some calcium after 4 or 5 days, which will improve their strength, and it can come out. You have to open the lid and it will come out of its own, out of the bowl. This we have taken out and washed it and kept it. But we were not interested in growing chicks in bowls, but it was a matter of interest, and we could see that 94% survival rate of embryos in the shellless culture system up to 8 days. So my aim was fulfilled, that I wanted it to grow up to 96 hours. So all embryos were nicely alive. So next slide. Then we focused on stages of active organogenesis, like Hamburger-Hamilton staging 7 to 9, when primitive streak is developed, then how head, thoracic region and lumbar region is developed, and torsion, when all organs are developed, brain, primordial brain, optic vesicles, limbs, everything is developed at 72 hours. After that, 96 is still more development. So we focused on this, and 2 hypoglycemic concentrations, hyperglycemic concentrations with reference to birds, that is 50 millimolar and 100 millimolar glucose. That was, we could get it from the literature search, where decided to be checked. And glucose-induced malformations in mammalian fetuses due to diabetic pregnancy, which were reported by using mammalian model. We focused on seeing whether we can see such malformations in the developing embryo by generating hyperglycemia by addition of this glucose. Next slide. So the scheme of work was fertilize eggs, incubate for 20 hours, make shellless cultures, saline, mannitol, glucose, whatever you want to add as a control, add as a agent. It should be added only in 50 microliters, not more than that, whatever your concentration is, because that drop should not roll off the yolk ball. So that was again tried many times, how it will remain on the disc, on the embryo, how it will get absorbed. So it should be only in 50 microliters. Incubate it for 24 hours and then harvest the embryos with the help of paper ring, wash them, and you can photograph them and correlate glucose-induced malformations observed in chick embryos with those of the glucose-induced malformations observed in mammals using mouse, rat and other mammalian models. Next slide. Next slide, please. So when it was a very early stage of organogenesis, 24 hours incubation, you can see a control embryo will develop into an embryo like this. Whereas with 50 millimolar glucose, there was 70% mortality, and you can see a zigzag nervous system. Spinal cord region has become zigzag, which is abnormal. And 100 millimolar glucose, you can see mortality was 90%, but open neural tube you can see, that is exencephaly, which was the developmental defect, which is very common in diabetic pregnancy offsprings. So this was observed. So mortality rate was very high when embryos were very young, and the increase in concentration it increased. Next. This was treatment of glucose to Hamburger-Hamilton stages, 12 to 14. That is hours of incubation, approximately 48 hours. Again, a normal untreated embryo will develop into, that is 48 hours. So 48 hours embryo will develop into 72 hours embryo, normal development. With treatment of glucose, you can see a variety of abnormalities, morbidities like embryonic dysmorphogenesis. But these embryos were live, only not dead embryos were counted, only live embryos with morbidities were counted. Abnormal brain and heart development, embryonic dysmorphogenesis, malformed heart, abnormal heart, and many such things. So mortality was less, but morbidity was more when the embryonic age was higher. Next. This was the third active organogenesis stage, that is Hamburger-Hamilton staging 18 to 20, around 22 hours. And as the embryo grows, you can see that the mortality is less, but morbidity is more. Embryos were alive, mortality was less, but abnormalities were very high. And you can see typical macrosomia, entire body weight is high, or macrocephaly when only head is larger inside. These are normal observations of diabetic pregnancy in human beings. These are normal. Fetuses are alive, they are born but with abnormalities. This was already recorded and reported in the literature, making use of mouse, rat, and other mammalian models. So next slide. This is the integrative chart which shows how it was done, and it is not a particular cardiac or nervous system morbidity, but it is a morbidity of nervous system or heart or dysmorphogenesis. So variety of nervous system abnormalities were reported in particular concentration and particular stage of development. Next. So those glucose-induced malformations which were observed in chicks were similar to those which were reported in mammals using mouse or rat or mammalian models. So that this paper immediately got accepted in a journal of poultry reviews of diabetic studies, I think, where it was because alternative to mammalian experiments and alternative to animals also. Because it is also, as per the law, developing chick embryo up to 10 days of death, 21 days are required for chick to hatch out. So up to 10 days of incubation is not considered as an animal, because it is reported that up to 10 days of incubation, the chick embryo doesn't have the pain sensation. And under the law, till the pain sensation is not there, it is not considered as an animal. So all my work is alternative to mammals and alternative to animal experimentation. It got immediately accepted, and this paper still gets maximum hits. And you can see on Google, shellless chick embryo culture system. This is the first paper which will appear. Next slide, please. So, making use of this system for diabetes research, I studied it for my PhD. Then I did around 24 MSc projects. You can use this system for, exploit this system for studying so many things. So, a simple experiment of what happens with hyperosmotic solution of glucose. Glucose concentration is correct, because glucose solution you have to make in 0.9% saline. You have to maintain osmolarity also. So if I have not done that, what will happen is a simple project for my PhD, for my MSc student, with morphological abnormalities followed by biochemical, followed by histology, everything can be studied. Similarly, hydrocephalus, effects of alcohol consumption during pregnancy. Fetal alcohol syndrome is a very common occurrence, and it can be studied using this particular. So, n number of projects can be done using chick embryo as a model system. Even the effect of mobile radiations, effect of sound waves coming from them, which is a common thing which occurs during pregnancy nowadays. We also studied effect of anti-diabetic Ayurvedic preparation Jamba soap. It is used as a known anti-diabetic preparation. What happens, really how it works, using chick embryo as a system. Whether it really, simple test by Benedict's test, you can see whether the glucose is less, glucose is high, then calorimetric test. But for MSc projects, I used it, exploited it for so many different things. So you can really use this chick embryo as a model system for testing many more things. Next slide, please. This is another wonderful application which I made, making use of chick embryo as a model system. This was like neuronal and cardiac toxicity of pharmacological compounds identified through transcriptomic analysis of human pluripotent stem cells derived embryoid bodies. A very nice paper, you can read it in toxicology and applied pharmacology. This is a collaborative work from me, Dr. Bunde and Dr. Rajarshi Pal from Bangalore. So in this, like embryonic stem cells are used as a model system for drug testing. But instead of that, if he wanted to see induced pluripotent stem cells and converting them into an organoid body, which mimics development of ectoderm, mesoderm and endoderm, whether it can be used as a model system for drug testing and many things. So when he tested it for pharmacological doses of certain compounds, he found that there is not proper differentiation of ectoderm, or with some other medicine, not proper differentiation of mesoderm, and he wanted to validate this, right? So we use this chick embryo model where we applied the pharmacological doses to the embryo, and if it is the ectodermal differentiation is getting problem, there should be some neuronal deformity in the developing embryo. Like that, neuronal and cardiological toxicity of pharmacological compounds identified through transcriptomic analysis, gene expression protein analysis was done, but validation was done using chick embryo, a one step behind to mammals. Whether these doses will really, number one, and number two is whether induced pluripotent stem cells can be used as a model system instead of embryonic stem cells was our aim. So this we validated using developing chick embryo. Next slide, please. So during studying development of chick embryo in the bowl, we can see that there are these four different embryonic membranes like amnion, yolk sac, allantois and chorion are extra embryonic membranes which are developed during the development, and out of which on the 8th day chorion and allantois unite to form a vascular chorioallantic membrane, and this CAM has been used in the literature and routinely used till today for angiogenesis studies, because it is a well vascular membrane. What angiogenesis is formation of new blood vessels from the pre-existing one. So any compound, if you want to test whether it is the angiogenic or anti-angiogenic, it can be checked with the help of CAM, right? But while observing those embryos in the bowel culture, I could see that yolk sac, which develops on the 3rd day, 72 hours, is also a vascular membrane. Then why it is not used as a model system? Next slide, please. Because CAM starts at 8th day. Development of CAM starts at 8th day. You have to set up the experiment on 9th or 10th day. For that, you have to hold the egg horizontally. From the egg space, air space, you have to remove small amount of thin albumin so that it will go down, and then make a window on the top. Treat the vasculature, not the embryo. Treat the vasculature, cover it, incubate it, and then take it out. And CAM is very large. By 14th day, by 13th day with this, the embryo is quite large. You cannot photograph CAM from the window. You have to open the entire egg, take the entire contents in a big petri dish in saline, sometimes excise the CAM, and then take the photograph and make counting of blood vessels to study whether the agent was angiogenic or anti-angiogenic. So I found that this is a very clumsy and time consuming, also expensive, and also needs animal ethical clearance after 10 days. So I thought that, next slide please. what was reported in the literature was YSM, although is a very highly vascular membrane, cannot be used as a model for angiogenesis studies because the embryo is too young, too delicate, just upper to the shell, and their mortality rate is very high. I will show another reference that it is a scientist who has reported that it can be used for toxicological studies but not used for the angiogenesis study. What we thought is candle the egg after incubation, 72 hours eggs, candle them and position the embryo whether it has developed blood vessels, and then make it vertical incubation for this system, not horizontal, because embryo will be just up. Just candle it and locate its position, and from the narrow end make a small aperture and take out the thin albumin with the help of a micropipette. Around 5 ml albumin can be easily taken out. The reason was it will take the entire embryo and everything little down towards the equator, so that there will be sufficient space I will get from the top to work, because that was the reason given by the scientists in 1990 that it cannot be used because the embryo is very delicate, immediately just below, and it gets injured and the YSM cannot be used. Compared to that, CAM is sturdy and it should be used for the angiogenesis study. So what we did is like this: remove the albumin, again close it with the tape, and applied angiogenic agent, whatever we want, angiogenic, anti-angiogenic, which we want to test, not on the embryo. It is not the place of application now. We wanted to use membrane as a model because it is a vascular membrane, whether the agent promotes angiogenesis or inhibits angiogenesis. So add the 50 microliters of the agent properly diluted in 0.9% saline on the vasculature, not near the embryo, away from the embryo, because angiogenesis is vessels of vessels. Because like cancer, why a cancer can grow? Because the cancer cells secrete factors in the vicinity which attract endothelial cells in the nearby blood vessel to proliferate and move towards the cancer or the tumor and form a tubule so that it will get nourishment through the blood. Right? So that vessels of vessels are formed. So that this agent should be applied on the sides where there is a very light vasculature which is developed. And then close it, again incubate it for 24 hours. After 24 hours, you can remove the tape, cut open the entire above empty shell which we had made to, for the embryo to go down, and completely open the expanse of blood vessels like this. You can photograph it in situ. You don't have to take it out, and then next, you can count it in this way. The one which is near the embryo is primary vessel, which is default, it has to be there. Bifurcation of it is secondary, then tertiary and quaternary. Quaternary vessel formation is which is going to be affected with angiogenic or anti-angiogenic agent. Right? So we can count them. This is a photograph of YSMs captured using an Olympus camera. And then the images were cropped, resized to this particular pixels, and number of primary, secondary, tertiary, quaternary blood vessels was counted manually using ImageJ software. So that you can count these blood vessels and can plot a graph of number of vessels versus types of vessels. What is the number of primary vessels, secondary vessels, tertiary vessels, quaternary vessels? Number of vessels versus types of vessels, if you plot, you can easily see which vessels have increased in number or decreased in number. And naturally, primary and secondary are not going to get affected much. What is going to get affected is tertiary and quaternary, vessels of vessels. If your agent is angiogenic, this number is going to increase than the control. If your agent is anti-angiogenic, number of these vessels is going to decrease as compared to the control. Next slide, please. So we did lots of experiments. You can see control, VEGF, which is a known angiogenic substance, and avastin, a routinely used anti-angiogenic substance. You can easily see in the area of tertiary vessels how the tertiary vessel number is less. Then this is arginine is also non-angiogenic substance. There are two methods of application of the agent. Either you release them directly on the membrane or you release them on a disc of Fortman paper number 2 and put the disc wherever you want to put it, not near the primary, secondary, but outside. If it is an angiogenic substance, you can see a typical spokes will like pattern develops because it will attract the formation of new blood vessels from pre-existing ones. Of course, this is called a focal application. With focal application, counting becomes difficult. So I routinely do this non-focal application. Take the photographs cleanly and then you can make the other adjustments for its brightness and others and count them correctly with image software. Next, then we try to compare our counting with the established CAM system, whether the results are similar. We also can do CAM. So we did CAM as well as YSM, which we were developing, and plotted the graph which gave the comparable results. Trend is same. Like if an agent is anti-angiogenic, it will show anti-angiogenic effect and anti-angiogenic counting of vessels in CAM as well as in YSM. So we proved it with that and significant increase in the number of quaternary blood vessels with angiogenic and decrease with the anti-angiogenic agent. Next slide please. Then we used a number of things to check whether this model really works. So we used avastin, vitamin C on both YSM and CAM and showed that it is a comparable results. We use a number of things like conditioned medium of stem cells, conditioned medium of islets, directly islets, whether they are angiogenic. Next slide. So this was the project for Avishkar, which my PhD student, she presented. Rucha, you can see she is in the center. She was awarded first prize at all levels, national levels and all, for the YSM model which we did. Next. So that in OVO-YSM model, which has been reported in the literature for toxicological study, this Rosenbrook in 1990, he reported that it cannot be used for angiogenic studies. We established its suitability as a substitute to CAM for angiogenesis studies for different types of agents. And this also we published in Cell Biology International. And I'm very happy to share with you that we have received a mail from editor of Cell Biology International that thank you for submitting this piece of work to our journal. This has improved our impact factor. So it was a very nice feeling for me that I was fighting. Thank you so much. Thank you so much. Because that is what makes us happy. And I was fighting with the scientific community for so long that how YSM is better than CAM. So long. And after that it got published, and after 1 or 2 years I received a mail from the editor. Next slide please. So since it was, this was my PhD, Rucha's PhD topic actually, that characterization and diabetic wound healing efficacy of polycaprolactone gelatin matrix intracellular secretomes. So mesenchymal secretomes which have wound healing capacity, we were checking whether they really have wound healing capacity. And we actually, this is also we have a patent that how to collect these secretomes was a problem actually. So we developed a method that we grew them on some matrix, gelatin, this polycaprogelatin matrix. It has come to us from BRC to see its compatibility with the cells and biological systems. We grew our cells, MSCs on this, and we found that the matrix gets turbid after growing. So we thought that it must be the secretomes which are getting imbibed. Then we squeezed them, characterized them, and we wanted to see whether it can be used as an ointment for diabetic wound healing, right? Secretomes. So first requirement is whether it is angiogenic or anti-angiogenic substance. We checked its angiogenicity using this YSM model. So this was a part of Rucha's project also. It started with some MPhil person's project. So with 2 students we completed this, and then we could do many things. Next slide please. So once it was in Avishkar, many people come to see it. So many Ayurvedic companies like Rasayani Biologics Private Limited is a well-known company in Pune who prepare potential anti-cancer drugs. So they came to us for MOUs and we screened large number of their anti-cancer potential drugs to check whether these are anti-angiogenic, because that is the first step. That is not the entire thing. You have to do so many assays, but at least first checkpoint that whether the drug is anti-angiogenic, and because every anti-cancer drug must be anti-angiogenic. So we could do lots of MOUs when I was in SP College. So this was, all these are code names, NTX and NTX, VGTX. These names are code names for Rasayanic Biologics. You can see next slide please, which showed that their drug is anti-angiogenic at different concentrations. The simple thing, the graph of number of vessels versus types of vessels used to be drawn. Right? Next, again we did Association for Research in Homeopathy is another institution which is in Mumbai. They also made MOUs with us. We checked so many homeopathy drugs for different things. Like arnica was found angiogenic, Protalus was found anti-angiogenic. Immediately from the graphs we can find it. These were also potential anti-cancer drugs. Next. This is a very wonderful finding. I have videos of it. If you are interested, we can see, and if we have time. That we try to use this YSM to study screen effects of homeopathic medicines on hemorrhage, coagulation, and vascular lysis. Hemorrhage, coagulation, and vascular lysis of homeopathic drugs. Again, a collaborative project with ARH, Association for Research in Homeopathy. So you can see in the video also that diffuse hemorrhage immediately within 20 seconds with the effect of 50% dilution of millefolium 200 CH, homeopathic drug. Another was effect of 100% concentration of millefolium on blood vessels led to immediate clotting, shrinkage of blood vessels and death of the embryo. You will also see in the video that one concentration is hemorrhagic, another concentration is coagulative. I think homeopathic drugs function like this. That was their principle, that at one concentration they are hemorrhagic, another concentration they are coagulative. We have a very nice video for that. Next. So in addition to that, actually I have worked with Dr. Anjali Shiras, who was a cancer biologist in National Center for Cell Sciences. Also Dr. Satish Patki from Kolhapur, if you have heard his name, very good gynecologist and known for IVF center and IVF babies. So his project was like, if we can increase the window of implantation in the IVF, if we can increase because embryos are cultured in the incubators and the patient is given different hormonal injections so that uterus will be developed. But these two times do not match. When the uterus is ready for conception and the blastocyst is ready for transfer. So actually these don't match, and that is why success of IVF all over the world with lots of research in it is not more than 25 to 30%. So Dr. Patki was one of my collaborators. He was saying that if we can lengthen the window of implantation, because what happens is once it is developed, it undergoes menstruation. It is shaded off if the embryo is not there. And you have to wait if the blastocyst is not ready in the incubator. So at the time of transfer, actually many times doctor 100% know whether this will get implanted or not. If it is early, it doesn't get, embryo is younger, it doesn't get implanted. If it is older, it doesn't get implanted. If uterus is not ready, shaded off, it doesn't get implanted. Everything is known, but you have to complete the cycle. So to improve the rate of IVF, Dr. Patki was trying to make some formulations. It was very confidential. I cannot tell the names of the formulation. Also, the research is not published, but it can be such formulations can be just released at the uterus level so that it will hold developed uterus, which is angiogenic at that time. So if it is an angiogenic substance, it will not allow the uterine endometrium to shed off. And if we can get some hours and can widen the window of implantation, the success rate of IVF will be improved. So that was the project which we had done. It is in practice, but it has to come in statistical number. then it will come out. So that this YSM was used for that. There are so many other applications also which we made using yolk sac membrane as a model system. And in addition to that, as I told you that even chick which is hatched out, it is also still developing. It is not an embryo, but it is a young chick. So 4 days old chick's pancreatic islets, we have shown that can be used as a model for diabetes research. I am not showing those things here, but those islets, because otherwise birds maintain a very high level of glucose in the body. 350 to 400 mg per dl is normal glucose level in birds. So everywhere it was given in the literature that chick islets cannot be used for diabetes research, because what islets they were used to use are broiler chicken islets, at which the blood sugar level was very high. While doing the chick embryo culture system, shellless culture system, we just started taking out the blood from the time heart was developed and seeing its glucose level with the glucometer. So that we found that this blood glucose level gradually increases. And when the chick hatches out and is at 4 days old chick, the blood sugar level is around 200. So which matches the diabetic man. So we isolated islets from this chick, and of course protocol was different than which was applicable for broiler chick. We immediately again could publish this protocol, and then we showed that these are functional islets by giving glucose induction and seeing that they secrete insulin. And while culturing these islets, we used to culture islets and take the islets out for experimentation. What I used to see that some cells get adhered to the substratum of the culture vial. I used to feed them and passage them. Like that I could passage them for like 19 passages, 20 passages. So my guide said, what are you doing? You are doing passages and these cells. So I said, what I should do? He said that now it is more than 20 passages, we should check its stem cellness, whether they are stem cells. Then we characterize their stem cell nature. And once we know that they are stem cells from chick, we differentiated them into islets. Right? Because my interest was diabetes research. We didn't differentiate them into some other lineages, but differentiated them into islets. And now these islets have not seen any glucose title. We transplanted these islets into diabetic mice in the kidney capsule, or also putting them in a bag and then in the peritoneum. And we could see that it brings normoglycemia in mice. Transplantation of islets differentiated from chick pancreatic stem cells. So this was accepted in a stem cell conference in Cairns, Australia, and we made a presentation of that. But unfortunately, there were not so many different antibodies which were developed for the chick, so that we could characterize these islets and stem cells very well. We used to go by negative finding that the antibodies for human beings we used to use, and if it is not giving the result, that it was not 100%, only Chemicon company used to give, provided us 2 vimentin and 1 more antibody, so that we characterized the cells. But we differentiated them, we studied their insulin production capacity, we transplanted them into diabetic mice, and we could see that it brings. So all these things can actually function as a model chick, not only developing chick embryo, but chick as a model for biomedical research. In addition to that, it supports the 3R principle, like reduction, refinement, and replacement of laboratory animals for experimentation. Because it is not considered as an animal up to 10 days of incubation, it is not considered as a mammal also. All our work got published in international journals only because it was alternative to mammals, it was alternative to animals. Because this work was good, but it was a major cause that we were showing that it is the alternative to animal experimentation and use of mammals for experiments. So with this, I think we can conclude that developing chick should be exploited for its use. We used chick trachea, made a hanging drop culture of its slices, and studied the effect of camphor, ethanol, smoke, nicotine on the ciliary activity and secretion of mucus on this. Thin slices of chick trachea can be taken out. They can be put on the lid of the Petri plate, and a 30 microliter medium drop should be kept there and make a hanging drop. And whatever agent you want to check should be kept in the petri dish below, so that its fumes will be taken up by the cells of the trachea, and we can easily see through the microscope the excess of mucus secreted or the ciliary movement. That is also one paper which we have published. So we can exploit chick as a model for all different aspects of biomedical research. So thank you so much for inviting me and giving me an opportunity to share my work. Next slide, please. Next slide. This is the place, Parshurabhav College, where I was working. I worked there for 35 years. Last 2 years I worked as a principal of this college. Thank you to Chick also. And there are some videos if you are interested, otherwise you can see it anytime. Some hemorrhage and other videos if you are interested, not bored, then you can see these videos. फक्त म्यूट करा, त्याच्यामध्ये आय एम टॉकिंग समथिंग विथ माय स्टुडंट, ते नसलं तरी चालेल. फक्त यू कॅन सी हाऊ इट शोज हेमोरॅजिक डिफ्यूज हेमोरॅज, and at one concentration it is hemorrhage, another concentration it is coagulation. These are all in biochem. We did not have to take embryos out, nothing. This I was putting, I ruptured it and then added the milefolium at particular concentration, which was given to me for testing whether it is hemorrhagic, whether it is coagulative, what it does. So after some time, oozing of blood stopped. I washed it with saline and you can see that it has stopped and the embryo is alive for next so many days. Washed it with saline and then saw that it got sealed up. The vessel which was ruptured with the needle got sealed up and normal circulation was restored. Forward it, you can forward it, or you can show another one also. You can see that where the saline was added, no blood is coming out. That was the place which was ruptured. Forward it or show the another video. These are different concentrations which were tried, but one was for hemorrhage. Diffuse hemorrhage is seen very nicely. Not in this, another one. Yes, you will see the diffuse hemorrhage here. Little forward. Can you see the hemorrhage? By addition of particular agent, whether it is hemorrhagic, coagulative, embryo is live, agent is added on the membrane, vascular membrane. Enough, I think. Thank you so much.
Thank you so much, ma'am. Any questions? On behalf of LTIPS, I would like to express our heartfelt gratitude to Dr. Datar ma'am for her informative session on developing chick embryo as a model system for biomedical research. Your expertise and in-depth knowledge have provided us with a fresh perspective on the importance of chick embryos in advancing biomedical research. The way you explain the model's relevance in understanding human diseases, organ development, and drug testing was nothing short of fascinating. We are sure that everyone present today has gained valuable insights that will help in shaping future research endeavors. Thank you for sharing your time, research, and knowledge with us, ma'am. Thank you once again. I now request Registrar LTIPS, Dr. Deshmukh ma'am, to felicitate Dr. Datar ma'am as a token of appreciation and gratitude. Please, ma'am. Before we move forward, a heartfelt thank you to our esteemed sponsors, Lab India Private Limited and Shalgar Hosiery Pune, whose generous support has made this conference possible. Your commitment to fostering growth, innovation truly elevates this event, and we are incredibly grateful for your partnership. Now, I request Mr. Anand Patil, sir, who is a business manager, Lab India, to start with his presentation. Please, sir.
So I'll just introduce myself. I'm Anand Patil. I'm working in Lab India from last 15 years. Lab India is basically an analytical instrument company. We manufacture some product. We'll share this in our this catalog and our presentation we are going to cover today. So, firstly, I'd like to thank Lokmanya Tilak Maharashtra College and the authorities who have given us the opportunity to show our instrument range, what we have, and to promote. So, firstly, we start with Lab India analytical instrument. So, we have this Make in India concept. So, what is Lab India basically? So, we manufacture some products like which are required for pharmaceutical basically, chemical industries, oil industries, perfume industries, industries like which is related to testing laboratories, like pH meters, conductivity meters that we will cover in the sector. So food, petroleum, chemical, formulation, pharma, all these instruments we manufacture. We have a manufacturing facility in Rabade, in Mahape, and we have our head office in Thane, and we have a branch office in Thane, Pune. So we started this in 1980. There were 4 engineers who started this organization. Then we started with 86 with some a good brand called PerkinElmer. People must be aware of PerkinElmer. Basically, they deal in chromatography and spectrophotometers. Then it came to 2006, 2007. Lab India came into manufacturing product. Then in 2009, 2010, we captured it with a good agency product like FTIR, UV visible spectrophotometer, ICP-OES, and some products which are related to CEM agencies like microsynthesis, microdigestion, microextraction, microfurnace. Then we come on to this. Now we have some agencies which are related to life science product line which we cover, like magnetic stirrers, oven, centrifuge, homogenizer, which we are covering in my latest slide. And we have some products which are related to food product like protein estimation, fiber estimation, fat estimations. So we have this manufacturing facility in Mahape. You can see the machine shop. We manufacture each and every part. This Make in India concept which has been being by our government from 2015. So we are introduced this facility. We are doing good in this. This is for CNC facility, production and quality control lab. Now we have some agency product line for CM, like CM digestion, CM synthesis, CM extraction, CM furnace. Then we have thermofusion scientific for FTIR, higher end FTIR, mid-IR range, near-IR range, far-IR range. And we have Magritech for benchtop NMR. People must be aware of floor model NMR. We have benchtop NMR and Alvotech for XRF and EDXRF model. We have this application lab, as I have already told Meera ma'am that you can very well attend to our application lab where we have all this resolution type 1, type 2, type 3, type 4, and even some products which are related to spectrophotometers and chromatography. We have this training institute. We can even train the people over there for 1 or 2 days. Now what we have in manufacturing, we will cover that. We do have the export and service with this. We mostly cover the range of East Africa, African countries and the Gulf countries wherein we have the offices over there. We have resolution apparatus. People are aware what is resolution apparatus. We manage the people who manufacture tablets and capsules. They do the resolution activities. They keep the activities in the bowl, what we have in our stomach, and they just try to resolve in that level. So resolution activities are completely automatic system. People, customers like Lupin or NPO, they are having a set of almost 100 sets. So they maintain the temperature 37.5 plus or minus, and they manage to get this application. So we have this auto sampler available with us. This comes with 6+2 and 12+2 options. This is with 21 CFR compliance, which is the party level part of pharmaceuticals. We have this instrument with us. This is completely connected to HPLC, UV or UPLC. Then we have a physical testing apparatus like disintegration. The college is already using it. Fragility tester, tap density meter and leak apparatus. This is hardness tester with single carousel, 12 carousel, 24 carousel. This is to check thickness, hardness, tensile strength, length, height and width. So 5 parameters are covered in the tablet hardness tester. The small instrument pH meter, microprocessor based, GLP compliance, non-GLP compliance, pH meters, conductivity meters, combined system are also available with us. We have this in installations in pharmaceuticals and most of the industries. This is potentiometer, which we call almost cover 6 to 7 different types of reaction like acidic, base, redox, complexometric, argentometric, and we have Karl-Fischer titration to cover your moisture detection in the sample. Both the system can come in a 21 CFR compliance part. This is melting point apparatus, where you check a melting point which can go up to 350 degrees centigrade. You can get a melting range and a melting point both. So video capturing capacity, this is the most used instrument in pharmaceuticals. We have UV visible spectrophotometer. This will start with visible range, UV visible range, UV visible spectrophotometer with double beam technology with silicon diode, with PMD detector, with tungsten deuterium lamp, with xenon lamp, all the options are available. We have almost 13 different type of UV-visible spectrophotometers. This is the atomic absorption spectrophotometer. This will cover your inorganic impurities in your sample. Like you have option of getting boron, which is atomic number 5, and uranium, atomic number 92. You can cover all your elements. Almost 72 elements are covered in atomic absorption spectrophotometer. This is basically made in food industries, chemical industries, pharma industries regularly. This is a new concept. It's called glacier washer. People are using in the industries. They don't want to waste their time. They use glacier washer to wash their trays, conical flasks, pipettes, vials, etc. We have automatic refractometer. We have automatic polarimeter. This can work with your chiral activity, refractive index, Briggs index in the sample, automatic. We have some product which is related to sieving, grinding, milling, sieve shakers, grinders, air jet sieve shakers, knife mills, ball mills, planetary ball mills are available with us. This is all we have. Planetary ball mill which can work up to 1 nanometer. Micro ball mill, a sample which is very tough to grind. We can take it into liquid nitrogen, almost minus 80 degrees centigrade, and we can grind it. Then we have instrument called sample divider, vibration tester, knife grinders, joggers. All this is related to sieving milling program. We have some good important customers. Basically, we work more with pharmaceutical. You can see we have a range of customers like Cipla, Johnson & Johnson, Abbott, Alembic, then Emcure, Alkem, Novartis, Unichem, Sandoz, Sun Pharma, Lupin. I understand most of your students, when they will complete their education, they will go in such kind of industry. So you have all the range of instruments in all the range of instrumentation in all the QC, QA, R&D, production, everywhere. Now this is what we have in an agency product line. We call it an XRF. So most of the people must have seen this at Goldsmith Place. सोनाराच्या घरी तुम्ही हे बघितलं असेल. People who is identifying gold content or silver content in the sample, they just take it and they do this direct sample analysis. You won't require any sample preparation technique. You just touch the sample and you get the content of the gold, silver, anything which is related to it. So basically used in the metal industries, copper industries, cement industries to identify the inorganic impurities in the sample. This is, we have an agency of CEM, micro digestion, then we have micro sequential digestion, then there is a fat moisture analysis you must have used in your college, you must be using it. Peptide synthesis, somebody is working on peptide, we have this product with us. Then microsynthesis, somebody is working on different, there are 100 and 150 different type of reactions we have. We can do your reflex reaction, hydrogenation into this. We have micro ashing system to do your sulfated ash. And we do have protein analyzer. We can do direct sample analysis into this. This is our extraction system. Something to be extracted from the sample. This is basically used in pharmaceutical, very widely used instrument. Then we have FEIR from Thermo Fisher. Basically, we are associated with them. And FDR is basically to know the applications in chemical, polymer, pharmaceutical, automotive, energy storage, food and beverage, gemstone, environment, education, academia. Most of the colleges, most of the industries are using FTIR to detect the organic impurities in the sample. We already have demonstrated many times, and then we can show the system. FTIR is basic requirement in the pharmaceuticals. NMR, this is a new concept. This is a flow model which we had. This is basically NMR, which is benchtop model. We can cover this. We won't require any gas like it's a very cryogenic field. You don't have any nitrogen gas, argon gas, helium gas for this. This hardly you can take on a bench and you can do your analysis. We have a range of life science product line also, like microvolume spectrophotometer, real-time PCR, autoclaves, and deep freezers. This is all available with our life science division, which we can be readily available with us. Then we have centrifuges, gel documentation system, bioreactors, and hot plate magnetic stirrers. We have flow cytometry and ELISA blood reader. This is all life science product line, but basically NCCS is our big customer for this. Then we have a food product line, which we have food, which is having with FSSI benchmark. We have automatic nitrogen protein analyzer, we have automatic fat substrate extractor, we have automatic fiber analyzer and moisture analyzer and analytical lines. Also we have life science product line, we have analytical product line, and we do have a product line which is related to food. These are our global business distributors where we distribute most of the time. See, most of the things that they covered in what we have in African countries. We do have something in South America. We do have something in Gulf countries and Southeast Asia. So we have we have some association with the channel partners. We do work with channel partners, and we have big base in India. We are having almost 13 offices all over India. This is all we have in India. We have office in Pune, Baner, as I told you, Chandigarh, New Delhi, Jaipur, Ahmedabad, Baroda, Indore, Visakhapatnam, Hyderabad, Chennai, Ankleshwar, Goa. So almost 70 sales people, 110 service people, 15 R&D people, 55 manufacturing, and others are 30. We, for instance, are the biggest Indian manufacturer in analytical instrument, more than 15,000 customer base. And then we have deliver quality services, application support is where we keep for this stand, and we have instruments which are very much innovative, and now we are complying to the part of 21 CFR compliance. So Lab India basically, as you have almost seen, is oldest company in organization working with analytical instruments. Most of the senior faculty must have used Lab India product line. Either they have used directly with Lab India, or there must be some instrument which are with PerkinElmer or Bruker, or somewhere with Thermo Fisher, CEM with Lab India. So Lab India basically is an oldest company in organization. In working with, in Pune we had an office from 1987. So NCL, ISER, and you say University of Pune are our very old customers. Thank you.
Now I kindly request respected Registrar LTIPS, Dr. Meera Deshmukh ma'am, to felicitate Anand Patil sir, Business Manager Lab India Private Limited, as a token of appreciation and gratitude. Please ma'am. Thank you sir. Thank you ma'am. LTIPS organized paper presentation competition on 30th January for UG category, PG, PhD and faculty category, which created a platform for recognizing and honoring the talents of participants. The theme for national level paper presentation competition was AI assisted innovations in pharmaceutical sciences. Now I request all the dignitaries to take their seats on the dais. Please ma'am, please sir. May I kindly request Dr. Prasad Thakur Desai sir and Dr. Datar ma'am to present the prizes to the winners. In paper presentation competition, under UG category, 42 candidates, and under PG, PhD and faculty category, that is PPF, 36 candidates participated. So the prizes, that is under UG category, where the first prize was shared by 2 candidates, Ms. Madhura Magdum from Indira College of Pharmacy, Pune, under the topic Drug Repurposing, Applying Yesterday's Solution to Tomorrow's Problem. Ms. Madhura Magdum. Congratulations, Madhura. Again, the first prize, Ms. Gayatri Chorge, LTIPS Pune, topic The Digital Pharmacy Era, Enhancing Healthcare Through Technology. Congratulations, Gayatri. The second prize shared among 2 candidates again. Vishal Girmane, LTIPS Pune, under the topic Molecular Modeling, Admix Analysis of Trigonella Phonicum Grassicum Compounds and Atorvastatin for Cholesterol. Vishal Girmane. Heartiest congratulations, Vishal. The next candidate, Riya Shinde, LTIP Khargar, under the topic Niacinamide Beyond Skin Care, Emerging Uses and Benefits.
Congratulations. Under PG, PhD and faculty category, the first position was shared by Mrs. Mukta Abhyankar from Kashibai Navale College of Pharmacy, Pune, with the topic Development, Optimization and Characterization of Co-crystals assisted with in silico screening of co-formers for solubility and permeability enhancement of routine. Congratulations, ma'am. Again, the first position was shared by Ms. Aishwarya Jain from Alana College of Pharmacy with topic Biofabrication of Zinc Oxide Nanoparticles from Saraka Asoka and assessing their antioxidant and antimicrobial activity. Congratulations, ma'am. The second position was secured by Anju KR from LTIP Kharghar with topic Experimental Animal Models to Evaluate Immunomodulatory Activity of a Plant Extract. Congratulations, ma'am. The second place is shared by Rishabh Dongre from Indira College of Pharmacy, Pune with topic Development of Silver Nanoparticles of Etoricoxib for Enhanced Anti-Inflammatory Therapy. Congratulations.
Please give a huge round of applause to all the winners. Heartiest congratulations to all the winners. Keep it up and good luck. Thank you all the dignitaries. I hope this prizes serves as a motivation for the winners to continue striving for the greatness and inspires others to embark on their own journey of success. Now I request Ms. Apurva ma'am to give vote of thanks. Over to Apurva ma'am.
Thank you, Sneha ma'am. As we express our gratitude, let us always remember that the highest form of appreciation is not just in words, but in living by them. The knowledge and passion shared by our distinguished speakers have truly been transformative. We are incredibly fortunate to have had this opportunity to learn from the leaders in the field of pharmaceutical sciences. First and foremost, I would like to express our sincere thanks to Dr. Sriram Inamdar for his informative presentation on recent research in oncology. Your deep expertise and vision for the future of oncology have broadened our understanding of personalized medicine and its potential to revolutionize the cancer care. Secondly, we express our heartfelt gratitude to Dr. Vandana Patravari ma'am for a session on nanotechnology in healthcare. Your groundbreaking work and knowledge in nanotechnology continue to inspire innovation, making it more precise, effective, and accessible. Heartfelt gratitude to Dr. Prasad Thakur Desai sir for presenting views on innovations in herbal drug development, combining traditional knowledge and modern pharmacology. Your expertise in integrating age-old wisdom with cutting-edge scientific research opens up new frontiers for the development of safe and effective herbal medicines that could address a wide range of health challenges. Our sincere gratitude goes to Dr. Savita Datar ma'am for her engaging presentation on developing chick embryo as a model system for biomedical research. The insights you have shared on the chick embryo as a model for advancing biomedical research have highlighted the tremendous potential this system holds in uncovering the mysteries of human diseases and advancing the drug development. A special thanks to Honorable Vice President TMV, Dr. Rohit Tirak sir for his visionary leadership. A special thank you to our director, Dr. Pranati Tirak ma'am, whose mentorship has been integral for the smooth functioning and success of this conference. Your leadership continues to guide us all. I would like to express our deepest appreciation to Principal LTIPS, Dr. Devdhar ma'am, for her constant support throughout the event. Sincere thanks to respected Registrar LTIPS, Dr. Meera Deshmukh ma'am. Thank you for your unwavering support. Your vision and dedication have made this event a astounding success. Heartfelt gratitude to all the TMV authorities for their integral support in the organization of the program. Heartfelt gratitude to our sponsors for the day, Lab India and Shalgar Hosieri for their generous sponsorship. Many thanks to the student volunteers for their efforts for today's program. Many thanks to the Mass Communication Department for all the technical support in the recording and broadcasting the program. Heartfelt thanks to Canteen TMV for delicious food for today's program. A heartfelt thank you to all the attendees, researchers, students, faculty and non-teaching staff, your professionals for your active participation and engagement in these sessions. Many thanks to everybody who we might have inadvertently missed for these contributions. As we conclude this exceptional event, let us carry forward the spirit of collaboration and innovation, May the ideas, discussions, and connections made here continue to inspire us to push the boundaries of science and create a lasting impact. Thank you so much.